In this video, we will see phasors. Phasors are the vector representations of sinusoids. So here we can write a phasor is a vector representation of sinusoid which have both magnitude and direction. Or we can write a phasor is a complex number. A phasor is a complex number which have amplitude and phase. So let's see what is meant by this. First of all, let's draw the graph. So this horizontal axis, again this horizontal axis is the real axis. It is called real axis, and this vertical axis is called imaginary axis. We have already seen that this horizontal axis is plus cos omega t, and here this is plus sin omega t. But in this case, this is real axis and this is imaginary axis, and here this is called phasor, and this length is represented by r. R is the magnitude of z. This is z, and this z is the phasor. It is a complex number which have amplitude and phase. Now here to here this will be the, from here to here this will be y component of phasor, y component, and from here to here this is x component. This is x, and this angle with reference to this real axis, it is phi. Now this phasor z can be represented in three ways. Number one is rectangular form. Let's write it here. Number one is rectangular form. So in case of rectangular form, z is equal to x plus jy. This z is a complex number. It is equal to x, that is this x component, it is on real axis, and then plus this y. But since it is on imaginary axis, we have to multiply this by this j. Then second is polar form. So in polar form, the phasor is represented like z is equal to r at an angle phi, where r is the amplitude and this phi is the angle, this angle. Then next is exponential form. Exponential form, z is equal to r e to the power j phi. Now suppose if we want to convert rectangular form to polar form, then here we can write rectangular form to polar form. Then if we want to convert rectangular form to polar form, then z is equal to x plus jy. This is the rectangular form. This is called rectangular form, and we want to convert it into polar form. So here we need r and phi. So r is equal to under root of x square plus y square, and phi is equal to tan inverse of y by x. Tan inverse of y by x. This is r and phi. So this is how we can convert rectangular form to polar form. Suppose if we want to convert polar form to rectangular form, then polar form to a rectangular form, then the polar form is given like z is equal to r at an angle phi. So we need x and y value. We need this x and this y value. First we will write here, this is the polar form. Now x is equal to r cos phi and y is equal to r sin phi. So this is how we will get the value of x and y. So from this z is equal to r cos theta, r cos phi plus j sin phi. Now we can take this r common from here. This is r here. So therefore z is equal to r in bracket cos phi plus j sin phi. Also remember that in case of exponential form, here we can write also z is equal to r e to the power j phi. So this e to the power j phi is equal to, but e to the power j phi is equal to this value, that is cos phi plus j sin phi. So this is about phasors. Again, let's revise it. A phasor is a vector representation of sinusoid. That means it have both amplitude and phase, or we can say it have both magnitude and direction. Then a phasor is a complex number which have amplitude and phase of a sinusoid. Now here, if we draw this on a graph, so this horizontal axis is a real axis, this vertical axis is the imaginary axis, and this line represents a phasor, and this angle is phi, and the amplitude is r. This is the magnitude of z, where z is the phasor. This z is a complex number. It have x component and y component. Then the phasor can be represented in three ways, that is rectangular form, polar form and exponential form. In rectangular form, it is z is equal to x plus jy. In polar form, it is z is equal to r at an angle phi, and in exponential form, it is z is equal to r into e to the power j phi. Suppose if we want to convert rectangular form to polar form, then r is equal to under root of x square plus y square, because we want to convert, if we want to convert rectangular form to polar form, then we need r and phi, and phi is equal to tan inverse of y by x. Now suppose if we want to convert polar form to rectangular form, then z is equal to r at an angle phi. This is the polar form. To convert this into rectangular form, we need x and y. So x is equal to r cos phi and y is equal to r sin phi. So since z is a complex number, so it will be real plus imaginary. We have to multiply this with j. So this will be z is equal to r. This we can take this r common. So r in bracket cos phi plus j sin phi. Also in exponential form, z is equal to r into e to the power j phi, where this e to the power j phi is equal to cos phi plus j sin phi. So this is about phasors. In this video, we will see phasor operations. First of all, if we want to add two phasors, that means addition. So addition of two phasor z1 plus z2, it is equal to x1 plus x2, this is the real part, then plus j y1 plus y2, this is the imaginary part. Also remember that addition and subtraction are better performed in rectangular form. So this is the rectangular form. So addition and subtraction are better performed in rectangular form. Now similarly for subtraction, if we want to subtract z1 minus z2, then this will be x1 minus x2 plus j y1 minus y2. First of all, we have to subtract real part, and after that we have to subtract the imaginary part. And also again remember that the subtraction is better performed in rectangular form. So for both addition and subtraction, we need phasors in rectangular form. Then next is multiplication of two phasor. So multiplication, suppose if we want to multiply two phasor z1 and z2, we have to multiply its magnitude, that is r1 and r2, and the angle will be added, that is phi 1 plus phi 2. Also remember that the multiplication and division, these are better performed in polar form. Here we can see for addition and subtraction, they are better performed in rectangular form. So here we can write rectangular form. For subtraction also rectangular form. For multiplication, the phasor should be in polar form. So this is polar form. Also for division, the division is better performed in polar form. So z1 divided by z2. Suppose if we want to divide these two phasors, so it will be r1 divided by r2 at an angle phi 1 minus phi 2. So here we can see for multiplication, we have to multiply its magnitude and the angle will be added. And for division, we have to divide the magnitude and the angle will be subtracted, that is phi 1 numerator angle minus denominator angle. Also the multiplication and division also better performed in polar form. Now next is number 5, reciprocal. So for reciprocal it will be 1 divided by z. So this will be 1 upon r at an angle minus of phi. So this is the reciprocal, 1 upon z is equal to 1 upon magnitude at an angle minus phi. Then next is square root. Next is square root. So if we take square root of this phasor, so it will be square root of magnitude at an angle phi by 2. So we have to divide this angle by 2. Then next is complex conjugate. Complex conjugate. So for complex conjugate, z is equal to, it will be represented like this. So it will be x minus jy, and also this is in rectangular form. Here we can write this is the rectangular form. Then in polar form this will be r at an angle minus phi, and this is called as polar form. And in case of exponential form it will be r, that is magnitude, multiplied with e to the power minus j phi. This is called as exponential form. It is the exponential form. So again let's revise it. For addition, first we have to add the real part and then imaginary part, and for subtraction we have to subtract the real part and then imaginary part. For multiplication we have to multiply the magnitude and the angles will be added. For division we have to divide the magnitude and the angle will be subtracted. For reciprocal it will be 1 upon magnitude at an angle, the angle will be negative, or opposite of this, whatever the sign here, if it is positive then here this will be negative angle, and here if it is negative then it will be positive here. So now next is square root. So for square root we have to take the square root of magnitude and then the angle will be divided by 2. Then next is complex conjugate. So for complex conjugate the sign here will be negative. So it is x plus minus jy. This is the rectangular form, and for polar form it is r at an angle minus phi. For exponential form it is r into e to the power minus j phi. And also remember that z is equal to x plus jy. This is called rectangular form. Also z is equal to r at an angle phi. This is called polar form. And z is equal to r into e to the power j phi. It is called exponential form. And also remember that r is equal to under root of x square plus y square, and this phi is equal to tan inverse of y by x, tan inverse of y by x. And also remember 1 upon j is equal to minus j, and j square is equal to 1. We can verify this in calculator. If we take this calculator in complex mode, then 1 upon this j or I is minus j, and if we take the square of this, then it is minus 1. So here this is minus 1, not 1. And one more thing is to remember e to the power j phi, e to the power j phi is equal to cos phi plus j sin phi. E to the power j phi is equal to cos phi plus j sin phi. So this is about phasor operations. Thanks for watching, and don't forget to share to this video. In this video we will see phasor transformation. So there is time domain representation and there is phasor domain representation. The phasor domain representation is also called as frequency domain. Frequency domain representation. In time domain, let's say the sinusoidal voltage is V of t and it is equal to Vm cos omega t plus phi. Now this is in time domain representation. In phasor domain representation or frequency domain representation, it is represented by capital V is equal to Vm at an angle phi. So this is the phasor domain representation. Then next is, let's say this is a current I of t and its time domain representation is Im cos omega t plus phi. Similarly, this in phasor domain representation, it will be represented by capital I is equal to Im at an angle phi. Now what if in place of this sin, in place of this cos, there is a sin? So it is represented like this: V of t is equal to Vm sin omega t plus phi. So before converting this into phasor domain representation, first we have to convert this into this cosine form. So it will be Vm cos omega t plus phi minus 90 degree. So when we convert this sine to cos, then we have to add minus 90 degree to it. Now we can convert this into phasor domain representation. So it will be capital V is equal to Vm at an angle. The angle will be now phi minus 90 degree. So it will be phi minus 90 degree. Now similarly for current, let's say I of t is equal to Im sin omega t plus phi. So again, before converting this Im sin omega t plus phi, this time domain representation into phasor domain representation, first we have to make it in cosine form. So it will be Im cos omega t plus phi. Now since we change from sine to cos, so it will be minus 90 degree here. Now we can convert this into phasor domain representation. So it will be I is equal to Im at an angle. This will be phi minus 90 degree. Now To remember this formula, when to add this minus 90 degree, let's go to the basics. So let's draw the graph. We know that on this horizontal axis, this is plus cos omega t, and here this is minus cos omega t, and on this vertical axis, this is plus sin omega t, and this is minus sin omega t. Now, if we want to create the formulas, then remember that the phasor rotates in counterclockwise direction. So this is the direction of rotation. That means if we move from this cos plus cos omega t to minus sin omega t, here we can see the difference is 90 degree. So here we have to add plus 90 degree. That means the formula will be cos omega t plus 90 degree. Here we can write cos omega t plus 90 degree is equal to minus sin omega t, minus sin omega t. Then number 2, suppose if we move from this cos plus cos omega t to this plus sin omega t. So here we can see the direction of rotation is this, and it is moving, we are moving from this, we are moving in clockwise direction, and this is the direction of rotation is counterclockwise. So here, and the angle difference is 90 degree. So here we have to add minus 90 degree because the direction is opposite. So here we have to add minus 90 degree. So the formula will be plus cos omega t minus 90 degree is equal to plus sin omega t. So let's write the formula. Cos omega t minus 90 degree is equal to plus sin omega t. Now next formula will be, if we move from this plus cos omega t to minus cos omega t from here to here like this, here we can see the angle is 180 degree and the direction of rotation is same like the direction of rotation of phasor. So here we have to add plus 180 degree. That means it will be cos omega t plus 180 degree, cos omega t plus 180 degree, it is equal to cos omega t plus 180 degree is equal to minus cos omega t. So it is minus cos omega t. Also remember that if we move from here to here like this, and here the direction of rotation is this, and we are going from this cos omega t to this in the opposite direction. So here we have to add minus 180 degree. So for this also we will get the answer minus cos omega t. So it will be number 4, cos omega t, we have to add minus 180 degree. So minus 180 degree, it is equal to minus cos omega t. Then next is number 5. Now if we go from here to here like this, so it will be the formula will be sin omega t plus 90 degree. So here this will be 90 degree. So here we can write sin omega t plus 90 degree, it is equal to, we get plus cos omega t. So this will be plus cos omega t. Then number 6, the formula will be like this, plus sin omega t, then from here to here, if we go from here to here like this, again the direction is opposite. So here we have to add minus 90 degree, minus 90 degree. So it will be plus sine omega t minus 90 degree is equal to minus cos omega t. Sine omega t minus 90 degree is equal to minus cos omega t. Then one more formula we can write. If we want to go from this sine omega t to this minus sine omega t, now we will write the formula directly. So it will be, here we can write number 7, sine omega t plus 180 degree is equal to minus sine omega t, and also remember that sine omega t minus 180 degree is equal to also minus sine omega t. So this is the formula. Like this we can create the formulas. If you like this video, then subscribe to this channel and don't forget to share to this video. Thanks for watching. In this video we will see an example on phasor addition. Question: if V1 is equal to 50 at an angle 60 degree and V2 is equal to 30 at an angle minus 50 degree, find V1 plus V2. First of all, we will write what is given. V1 is equal to 50 at an angle 60 degree, V2 is equal to 30 at an angle minus 50 degree. We want to find V1 plus V2. V1 plus V2 is equal to question mark. Here we can see it is given in phasor form. Also this V2 is given in phasor form, and we know that addition and subtraction are better performed in rectangular form. Currently this is given in polar form. So here we can write these both are given in polar form, and here we can write addition and subtraction are better performed in rectangular form. So first of all, we will convert this polar form into its equivalent rectangular form. So here V1 is equal to 50 at an angle 60 degree. The formula to convert polar form to rectangular form is, first we need to find x. So x is equal to r cos phi, and y is equal to r sin phi. Now here this is r and this is phi. So here we can write this is r and this is phi. So r is equal to 50 cos phi is equal to 60 degree. For this r is equal to same, that is 50, and sin phi is equal to 60 degree. So if we solve this, we get 50 cos 60 degree, it is 25, and here this is 50. Now in place of this cos, this will be sin. So it is 43.3. 43.3. Now its equivalent rectangular form will be V1 is equal to x plus jy. So it is equal to, the value of x is 50, it is 25, and the value of this y is 43.3. So this is the value of voltage in rectangular form. This is called as rectangular form. Now similarly we will do this for voltage V2. So voltage V2 is equal to 30 at an angle minus 50 degree. Now V2 is equal to 30 at an angle minus 50 degree. So again this is in polar form. To convert this into its equivalent rectangular form, again the formula will be x is equal to r cos phi and y is equal to r sin phi. And here this 30 is the r, that is magnitude, and this minus 50 is the value of phi. So if we solve this, we get r cos, that is 30 cos. Now this phi value is minus 50 degree. And again here this will be 30 sin minus 50 degree. So if we solve this, we get 30 cos minus 50 degree. 30 cos minus 50 degree, it is 19.28. So 19.28, and here this will be, if we replace this cos by sin, then we get the value of y. So it is minus 22.98. Minus 22.98. So we can write this as V2 is equal to x plus jy. The value of x is 19.28 plus j. The value of y is minus 22.98. So again this is the rectangular form. This is rectangular form. Now we can add V1 and V2. So therefore V1 plus V2 is equal to, the value of V1 is 25 plus j 43.3. 25 plus j 43.3, and the value of V2 is 19.28 plus j minus 22.98. So if we add them, first we have to add the real parts. So it is 25 plus 19.28. 25 plus 19.28, it is 44.28. 44.28, then plus j. Now this will be 43.3. Now we have to add the imaginary part. So 43.3, then here this is minus 22.98. 22.98. So it is 20.32. 20.32. So this is the value of V1 plus V2. This is in rectangular form. Rectangular form, but we need this value in polar form. So in polar form, this will be, now to convert rectangular form to polar form, we can use this formula. R is equal to under root of x square plus y square, and phi is equal to tan inverse of y by x. The value of this r will be, now here we can see the value of x is, this is the value of x and this is the value of y. So therefore r is equal to under root of x square, that is 44.28, plus the value of y is 44.28 square, plus y, the value of y is 20.32. So 20.32 32 square. So it is equal to under root of 44.28 square plus 20.32 square. 20.32 square. So it is equal to 48.71. 48.71 is the value of r, and the value of phi will be tan inverse of y by x. That is, the value of y is 20.32 divided by 44.28. So it is equal to tan inverse of 20.32 divided by 44.28. So it is equal to 24.65. 24.65 degree. So therefore the value of V1 plus V2 is equal to 48.71 at an angle 24.65 degree. So this is the value of V1 plus V2. It is in polar form. We can verify our answer. So here in calculator, if we put this calculator in complex mode, then 50 at an angle 60, this is in one bracket, then plus 30 at an angle minus 50. So it is 44.28. So here we can see in rectangular form it is 44.28 plus j 20.31 or 32. So it is same. So our rectangular form answer is correct. But now we need to check our answer in polar form. So let's convert this answer into polar form. So shift 2 and then 3. So it is 48.71 at an angle 24.65 or 64. So hence our polar form answer is also correct. So this is how we can solve the phasor addition. Thanks for watching, and don't forget to subscribe to this channel. In this video we will see an example on phasor addition. Question: if V1 is equal to 3 at an angle minus 110 degree. So here we can write given V1 is equal to 3 at an angle minus 110 degree and V2 is equal to 4 at an angle minus 120 degree. V2 is equal to 4 at an angle minus 120 degree. Then find V1 plus V2. So we have to find V1 plus V2 is equal to question mark. Here we can see this voltage V1 and this voltage V2, these are in polar form. This is called as polar form, and this is called as, this is also a polar form. Now the addition and subtraction, here we can write addition and subtraction are better performed in rectangular form. So before adding this V1 and V2, we have to convert this voltage V1 and this voltage V2 into its equivalent rectangular form. So again, let's copy this V1 and convert it into its equivalent rectangular form. So, to convert this polar form to rectangular form, we need the value of x and y. So, to get the value of x, the formula is r cos phi, and to get the value of y, the formula is r sin phi. Now here this 3 is r and this minus 110 degree is the value of phi. So if we substitute it here, so it will be 3 cos minus 110 degree, and here this will be 3 sin minus 110 degree. So this will be 3 cos minus 110. So it is minus 1.02, minus 1.02, and this will be, now if we replace this cos by sin, so it is minus 2.81, minus 2.81. Now the equivalent, its equivalent polar form, its equivalent rectangular form will be V1 is equal to r cos phi plus j sin phi. So it is equal to r cos phi is minus 1.02 plus j sin phi. Now in place of sin phi it is minus 2.81. Let's say this is equation number 1 and it is in rectangular form. So here we can write, this is the rectangular form. Now we will do the same for voltage V2. So V2 is equal to 4 at an angle minus 120 degree, 4 at an angle minus 120 degree. Again this is in polar form, so its equivalent rectangular form will be, we need the value of x and we need the value of y. So x is equal to r cos phi and y is equal to r sin phi. And here this 4 is r and this minus 120 degree is phi. So it is equal to r is 4 cos minus 120 degree, and here this is 4 sin minus 120 degree. So if we solve this, it will be 4 cos minus 120 degree, 4 cos minus 120 degree, it is minus 2. So this is minus 2, and here if we replace this by sin, we get the value of y. So it is minus 3.46, minus 3.46. So therefore V2 in rectangular form will be r cos phi plus j sin phi. Now this r cos phi is minus 2 and this j sin plus j as it is. Now this sin phi is, here this will be r sin phi. Here also this is r sin phi. R sin phi is minus 2.81 and here also it is r sin phi, and the value of r sin phi is minus 3.46. Now let's say this is equation number 2. Okay, again this is in rectangular form. Rectangular form. Now next step is to add V1 and V2. So V1 plus V2 is equal to minus 1 point. Let's copy it directly. Also, let's copy this. Now first of all we will solve the real part. So this will be minus 1.02 minus 1.02 minus 2. So it is minus 3.02 minus 3.02, then plus j minus 2.81 minus 2.81 minus 3.46 minus 3.46. So it is minus 6.27 minus 6.27. Now again this is in rectangular form. We have to convert this into its equivalent polar form. So to convert this into its equivalent polar form, we need the value of r and phi. So the value of r is calculated like this: x square plus y square, and the value of phi is calculated as tan inverse of y by x. Here the value of x is this value is the value of x, and this value is the value of y. So let's put it here. So it will be under root of minus 3.02 square plus minus 6.27 square. So it is equal to under root of minus 3.02 square plus in bracket minus 6.27 square. So it is 6.95. Now this value of phi, this will be tan inverse of the value of y is minus 6.27 divided by the value of x is minus 3.02. So if we solve this, we get tan inverse of minus 6.27 divided by minus 3.02. So here the value is 64.28. 64.28 degree. But this is not right, because if we draw the graph, then the graph will look like this. Here this is the real axis and this is the imaginary axis. Now if we draw V1, it is 3 at an angle minus 110 degree. That means it will be somewhere here like this. This is V1 and the angle is minus 110 degree, and the angle for V2, it is 4 at an angle minus 120 degree. So 4 at an angle minus 120 degree, it is V2, and this angle is here, it is minus 120 degree. That means their resultant will be somewhere here. That means the angle should be negative. So instead of this angle, we need the angle in this direction. So what we will do, we will add 180 degree. So if we add 180 degree to it, then the answer will be 64.28 plus 180 degree. What we will do, we will subtract it. Both are the same, but instead of adding, we will subtract it. Subtract 180 degree. So the answer will be in negative form. That's what we want. So 64.28 minus 180, it is minus 115. So minus 115 minus 115.72 degree. Now we can write V1 plus V2 is equal to V1 plus V2 is equal to this value 6.95 at an angle minus 115.72 minus 115.72 degree. So this is the final answer for this, and we can also verify our answer in calculator. So if we convert this rectangular form to polar form in calculator, then the answer will be like this. Let's check it. So minus 3.02 plus j into minus 6.27. Now we will convert this rectangular form to polar form in calculator. So shift, then 2, then 3. So here is the answer. It is 6.95. Here we can see the answer is 6.95 at an angle minus 115.72 or 71. So hence our answer is correct. Don't forget to share to this video, and thanks for watching. In this video we will see an example on phasor addition and division. Question: here we can see this is given in polar form and this is given in rectangular form. Also these two are given in rectangular form and we have to multiply it. Now first step is remember that addition and subtraction are better performed in rectangular form. Then also remember that multiplication and division are better performed in polar form. So first of all, what we will do, let's copy this given, and now we will convert this according to these two statements. We will convert rectangular form. We will convert this into rectangular form for addition and subtraction, and also we will convert this into its equivalent polar form for multiplication. So let's convert it. Now when we convert this polar form to rectangular form, so let's convert step by step. So it will be 20 at an angle minus 30 degree. So it is equal to, we need this in rectangular form. So it will be x plus jy. That means we need r cos phi plus j r sin phi. the value of r is, here we can write the value of r is 20 cos phi plus j 20. The value of phi is also given, it is minus 30 degree. So minus 30 degree plus j, the value of r is again 20 sin phi is minus 30 degree. So this will be, we can solve this in calculator directly. So 20 cos minus 30, it is 17.32. 17.32 plus j, if we replace this by sin, so this will be minus 10. So let's write minus 10 here. Now we can replace this by this rectangular form. So let's copy this as it is. Now let's change this. Let's change this into this. So we can directly copy it from here and we will put it here. Now we can easily add them. So this will be 17.32 plus 4. So this will be 21.32. Then this is the real part. Now we will add the imaginary part. So this will be j and this j. Also this is in minus j and minus j. So it will be minus j here as a common, or we can take this plus j as common term. Now in bracket this will be minus 10 minus 3. So it will be minus 13. Now in the denominator, here it is 4 plus j 9 and 5 minus j 2. So we have to multiply it, and we know that multiplications and divisions are better performed in polar form. So let's convert this rectangular form into polar form. First we will convert this 4 plus j 9. So it will be under root of, the formula to convert it into polar form is r at an angle phi, and the r is under root of x square plus y square. At an angle, the formula for calculating phi is tan inverse of y by x. So let's substitute it here. So it will be under root of x square, that means 4 square plus 9 square at an angle tan inverse of y by x, that means 9 by 4. So let's solve it. So it will be under root 4 square plus 9 square. So it is 9.84. 9.84 at an angle tan inverse of 9 by 4. It is 66.03. 66.03 degree. Also we will do the same for 5 minus j2. So 5 minus j2, it is equal to r at an angle phi. So it is equal to under root of x square plus y square at an angle tan inverse of y by x. So therefore this will be under root of 5 square plus the value of y is minus 2. So minus 2 square at an angle tan inverse of the value of y is -2 divided by the value of x is 5. So if we solve this, we get under root of 5 square plus in bracket -2 bracket close square. So this is 5.38 at an angle tan inverse of -2/5. So it is -21.80 -21.80 degree. Now we can replace these two rectangular forms by its equivalent polar form. So let's copy it from here and let's change the value of the denominator to this. Let's copy it directly. Multiply with this value. Let's copy it again. This will be in also bracket. Now we can easily solve this. So here this will be, the numerator will be as it is 21.32, then plus j minus 13 divided by, now first we have to multiply this 9.84 into 5.38. So 9.84 multiplied with 5.38. So it is 52.93. 52.93, and the angle will be added because we are doing multiplication. So the angles will be added. So it will be 66.03 plus in bracket -21.80. Again let's copy it and paste it here. Now let's simplify it. So it will be 66.03 plus in bracket -21.80. So it is 44.23. 44.23. Now this time we have to do the division, and here it is in polar form, but the numerator is in rectangular form, and we know that multiplication and division are better performed in polar form. So we need to convert this rectangular form into its equivalent polar form. So let's convert 21.32 plus j in bracket -13 into its equivalent polar form. That means r at an angle phi, and it is equal to under root of x square plus y square at an angle tan inverse of y by x. So this will be under root of x square, that means 21.32 square plus y square, that means -13 square, at an angle tan inverse of y by x. The value of y is -13 divided by the value of x is 21.32. So it is equal to under root of 21.32 square plus in bracket -13 square. 21.32 square plus -13 square. So it is 24.97. 24.97 at an angle. Now this will be tan inverse of minus 13 divided by 21.32. So it is minus 31.37, minus 31.37 degree. So now we can replace the numerator. So let's copy it. Now we can replace the numerator with this value. So let's copy it directly. Now we can easily perform the division here. So this will be 24.97 divided by 52.93. So this will be 24.97 divided by 52.93. So it is 0.471. 0.471 at an angle. Now this will be minus 31.37. Now this will be subtracted, that is minus 44.23. So if we solve this, we get 0.471 at an angle minus 31.37 minus 44.23. So it is minus 75.6, minus 75.6 degree. So this is the final answer. We can make the square around it, and this is in polar form. Now we can verify our answer in calculator directly. So in calculator we can directly substitute all these values. 20 at an angle minus 30 degree, then plus 4 minus this I into 3. 4 minus I into 3 divided by, in one bracket it is 4 plus I into 9, then multiplied with 5 minus I into 2. 5 minus I into 2. So it is equal to this value. It is in rectangular form. We will convert this into polar form. So it is shift 2, 3. So it is 0.47. Here we can see we got the answer as 0.47 at an angle minus 75.6. So hence our answer is correct. And this is how we can perform phasor addition, division and also multiplication. Don't forget to share to this video. Thanks for watching. In this video, we will see an example on phasor addition of voltages. Here, the question is, if V1 is equal to this and V2 is equal to this value, we have to find phasor addition of V1 and V2. So first of all, let's write what is given. So V1 is equal to minus 10 sin omega t minus 30 degree, and the value of V2 is equal to 20 cos omega t, 20 cos omega t plus 45 degree. So here, before converting this time domain, currently it is given in time domain format, we have to convert it into its equivalent phasor domain format. So before converting this into its equivalent phasor domain format, we have to make this minus sign into cosine plus cosine. Like here, for this V2 the format is correct, and for V1 we have to convert this minus sign into plus cosine. Now how we can convert this minus sign into plus cos? So let's go to the basics. Here on this horizontal axis, this is plus cos omega t, and on this vertical axis, this is plus sin omega t. Here this is minus cos omega t, and here this is minus sin omega t. Now the direction of rotation is counterclockwise, means in this direction the angle will be positive. So we want to convert from minus sign. So from minus sign to plus cosine. So we will do like this. Now we are going from this cos omega t to minus sin omega t. So here the angle will be positive 90 degree. That means the formula will be like this: cos omega t plus 90 degree, cos omega t plus 90 degree is equal to minus sin omega t, minus sin omega t. So in place of this minus sin omega t, we can substitute cos omega t plus 90 degree. That means if we add plus 90 degree here, then this minus sign will be changed into plus cos. So let's do this. So V1 is equal to this 10 as it is. So we will substitute 10 as it is, then cos, then the angle as it is, that is omega t minus 30 degree, omega t minus 30 degree. But here we have to do, what we have to do, we have to add 90 degree to it. So let's add 90 degree. So plus 90 degree. So this will be V1 is equal to 10 cos omega t, and this will be 60 degree. So plus 60 degree. Let's say this is equation number 1. Now V2 in cos form. So it is 20 cos omega t plus 45 degree. 20 cos omega t plus 45 degree. Let's say this is equation number 2. 20 cos omega t plus 45 degree. Now we will change this time domain. We will convert this time domain format into its equivalent phasor domain format. So let's convert time domain to phasor domain. Time domain to phasor domain. So this will be V1 is equal to, now this will be 10 at an angle 60 degree, and V2 is equal to 20 at an angle 45 degree. Now currently this is in phasor domain form, or we can say it is in polar form. So this is the polar form. Also this is the polar form. Now we will convert this polar form to rectangular form, because we know that addition and subtraction are better performed in rectangular form. So let's convert this V1 into its equivalent rectangular form. So it will be V1 is equal to, this will be R in bracket cos phi plus j sin phi at an angle, not at an angle. This will be the value for rectangular form. Now here we can see this 10 is R, and this will be cos phi. Phi value is 60 degree plus j sin 60 degree. So let's put calculator in complex mode, and this will be 10 in bracket cos 60 plus I into sin 60. So it is 5 plus J 8.66, 5 plus J 8.66. So this is the V1. Now same we will do this for V2. Let's say this is equation number A. Now for V2 is equal to same R in bracket cos phi plus J sin phi. The value of R for V2 is 20. So this will be 20 in bracket cos phi. The value of phi is 45 degree. So 45 degree plus J sin 45 degree. So if we solve this, we get 20 in bracket cos 45 plus I into sin 45 bracket close. So it is 14.14 plus J 14.14. So again this is V2 in rectangular form. This is called as rectangular form. Rectangular form. Also this is the rectangular form. Now what we will do? We will add V1 and V2 in rectangular form. So let's add V1 plus V2. So this will be, let's copy it directly from here. This is V1 and now we will add V2. So plus this V2. Let's copy it directly and paste it here. Now what we will do? We will add the real parts. So here the real parts are 5 and this 14.14. These two are real parts and remaining this 8.66 and this 14.14, it is the imaginary part. So let's add 5 plus 14.14. So it will be 19.14. 19.14 plus J. Now this will be 8.66. 8.66 plus 14.14. So this will be 22.8. 22.8. So this is the value for V1 plus V2 and this is in rectangular form. This is the answer in rectangular form. Now what we will do? We will convert this rectangular form to polar form again. So convert it into polar form. So to convert it into polar form, the formula will be V1 plus V2 is equal to R at an angle phi. The value of R will be under root of x square plus y square at an angle. The value of phi will be tan inverse of y by x. So this will be under root of x square. Here we can see 19.14 is x. So 19.14 square plus y square. The value of y is 22.8. 22.8 square at an angle tan inverse of y by x. The value of y is 22.8. 22.8 divided by the value of x is 19.14. 19.14. So this will be under root of 19.14 square plus 22.8 square. 19.14 square plus 22.8 square. So it is 29.76. 29.76 at an angle. Now what we will do? We will solve the angle. Tan inverse of 22.8 divided by 19.14. 19.14, so it is 49.98. 49.98 degree. So this is the answer for V1 plus V2. Now this answer is in polar form, or we can say it is in phasor form. So this is the polar form. Now next, here we can see we have to solve this in time domain format. So again, let's convert this polar form or phasor form to time domain. So it will be V1 plus V2 is equal to 29.76 in bracket cos omega t plus this 49.98 degree. So this is the final answer for this question. Don't forget to share to this video, and thanks for watching. In this video we will see an example on phasor integral and phasor derivatives. The question is solve for I of t. Now here from this equation we can say that this 4I represents the voltage drop across resistor, and this 8 integral of I dt represent the voltage drop across capacitor, and here this minus 3 di by dt represent voltage drop across inductor, and addition of all this is the voltage source, which is 50 cos 2t plus 75 degree. So here this 50 is the magnitude of voltage or maximum amplitude or maximum voltage. This 2 is the angular frequency, that is omega, and this 75 is the phase angle. So let's write it. Let's copy this equation first. So here we can write it is the voltage drop across resistor. This is the voltage drop across capacitor. Voltage drop across capacitor, and this is the voltage drop across inductor. This 50 is the maximum voltage, and this 2 is the omega, that is angular frequency, and this 75 represents phase angle phi. So currently it is given in time domain format. We have to convert this into its equivalent phasor domain format. So let's convert it. So here this will be 4I, so this will be 4. Before that we will write convert it into phasor domain. So this will be 4, and here magnitude of I, that is capital I, plus 8 into I divided by j omega. So this is how we convert this time domain into its equivalent phasor domain. Then minus 3I multiplied with j omega, it is equal to, now this will be 50. So here we can write 50 at an angle. The angle is 75 degree. Now here we can see the omega value is 2. So here we can write, since omega is equal to 2 radian per second, because omega is always given in radian per second. So we can substitute, in place of omega we can substitute 2. So let's simplify the equation. So it will be 4I plus 8I divided by j into 2. minus 3I multiplied with j multiplied with, in place of omega this will be 2, it is equal to 50 at an angle 75 degree. Again further simplify this, so this will be 4I plus, now this will be 8 divided by 2, so this will be 4I, and this 1 upon j, 1 upon j means minus j, so minus, now this will be 3 into 2, so this is 6, and this will be 6I into j. Now it is equal to 50 at an angle 75 degree. We can further simplify this. So here we can see this 4I is the real part and these two are the imaginary part. So if we solve this, so this will be 4I minus 6I, or here also it is negative, so this will be minus minus, so it will be minus 10 minus 10I. First we have to write this j, so let's write j first, and now this will be 10I. Now this is the correct format. It is equal to 50 at an angle 75 degree. Now currently it is given in rectangular form and this is given in polar form. Here we can see we can take this I common from here. So let's take I in bracket 4 minus j10 is equal to 50 at an angle 75 degree. Now from here I is equal to, here we can write I is equal to 50 at an angle 75 degree divided by 4 minus j10. Now here the numerator is in polar form and the denominator is in rectangular form, and we know that addition and subtraction are better performed in rectangular form and multiplication and division are better performed in polar form. So let's convert the denominator into its equivalent polar form. So this will be I is equal to 50 at an angle 75 degree divided by under root of x square, that is 4 square plus 10 square, or this will be minus 10 square we can say, at an angle tan inverse of y by x. So minus 10 divided by 4, minus 10 divided by 4. Now if we solve this, so it will be 50 at an angle 75 degree divided by, now this will be under root of 4 square plus in bracket minus 10 square, 4 square plus in bracket minus 10 square, so it is 10.77 at an angle, this will be tan inverse of minus 10 by 4, minus 68.19 degree. Now we can further simplify this as I is equal to, now this will be 50 divided by 10.77, 50 divided by 10.77, so it is 4.64 at an angle 75, then this will be minus, because we are doing the division, so it will be minus of minus 68.19 bracket close. So therefore I is equal to 4.64 at an angle, this will be 75 minus in bracket minus 68.19 bracket close, so it is 143.19 degree. So this is the value of current in polar form or phasor form. We have to find I of t. So therefore I of t is equal to 4.64 cos omega t. The value of omega is known, it is 2 radian per second. So, here we can write 2t and the angle is plus 143.19. So, this is the final answer for I of t. So, this is how we can solve phasor integral and phasor derivatives. Don't forget to share to this video and thanks for watching. In this video, we will see an example on phasor integral and phasor derivatives. Question: solve for v of t. Here we have to solve this and find the value of v of t. So, first of all, what we will do? We will copy this given part and paste it here in the solution. Now, here we can see it is given in time domain format. So, what we will do? We will convert this into its equivalent phasor domain format, or we can say frequency domain format. So, let's convert it. So, this will be 2v. Now, here it is the derivative. So, it will be into j omega. Then plus 5 into magnitude of v, that is capital V. Then plus 10. Now, this will be v divided by j omega is equal to, now here again it is given in time domain format. So, this will be 50 at an angle minus 30 degree. From here we can see that this 5 is the omega, that is angular frequency. So, here we can write, since omega is equal to 5 radian per second. So, if we substitute it here, then the expression will be like this. Now, this will be 2 into 5. So, this will be 10 v. We will write this j first. So, it will be 10 j 10 v. Then plus 5 v. Then plus, now here this is 1 by j. Now 1 by j means it is minus j. So, here we can put minus j, and in place of this omega this will be 5. So, 10 divided by 5, this will be 2. This v as it is equal to 50 at an angle minus 30 degree. Now, we will solve this. So, here we can see this is the real part. So, 5v as it is, and now this imaginary part 10v minus 2v. So, this will be plus j 8v. It is equal to 50 at an angle minus 30 degree. 5v, and this will be j 8v. So, here also we can see that we can take this v common. So, v in bracket 5 plus j 8, it is equal to 50 at an angle minus 30 degree. Now, here on this left hand side it is in rectangular form, and on this right hand side it is in polar form. So, we will take this on this side. So, v is equal to 50 at an angle minus 30 degree divided by 5 plus j 8. We know that addition and subtraction are better performed in rectangular form, and multiplication and division are better performed in polar form. So, what we will do? We will convert this denominator part into its equivalent polar form. So, this will be v is equal to 50 at an angle minus 30 degree divided by Now this will be under root of 5 square plus 8 square at an angle tan inverse of 8 by 5. So therefore V is equal to 50 at an angle minus 30 degree divided by under root of 5 square plus 8 square. 5 square plus 8 square, and it is 9.43. So it is 9.43 at an angle tan inverse of 8 by 5. So it is 57.994, that means it is 58. So 58. Now V is equal to 50 divided by 9.43. 50 divided by 9.43. So it is 5.30. 5.30 at an angle. Now this will be minus 30 and this will be minus 58 degree. So therefore V is equal to 5.30 at an angle. Now this will be minus 30 minus 58. So it is minus 88 degree. So this is the value for V, and it is in phasor form, phasor domain form, or we can say it is in polar form. But we need the answer in time domain, that is we have to find V of t in time domain. So therefore V of t is equal to 5.30 cos omega t. The value of omega is 5t and plus phi. The value of phi here is minus 88 degree. So this is how we get the answer in time domain format. Don't forget to share to this video. Thanks for watching. In this video we will see an example on phasors. Question: evaluate these complex numbers. Solution: first of all we will write what is given. So 40 at an angle 50 degree, then plus 20 at an angle minus 30 degree to the whole power 1 by 2. So first of all we will simplify this 40 at an angle 50 degree. So 40 at an angle 50 degree, we will convert this polar form. It is currently in polar form. So this is the polar form. So what we will do, we will convert before converting we will write here we have to do the addition, and we know that addition and subtraction are better performed in rectangular form. Currently it is in polar form. So let's convert this polar form to rectangular form. So convert rectangular form to polar form. So here it is 40 at an angle 50 degree. 40 at an angle 50 degree. This is in polar form. In rectangular form this will be r cos phi plus j sin phi. Here the value of r is, this is the value of r and this is the value of phi. So let's put it here. So this will be 40 in bracket cos phi value is 4t plus j sin 4t. We will solve this in calculator directly. So mode, let's put the calculator in complex mode. So take it in number 2. So 4t in bracket cos 4t, not 40, the value of phi is 50. So this will be 50, it is 50. So 4t cos 50 plus I sin 50. So it is 25 plus 25.71, 25.71 plus j 30.64, 30.64, and this is called as rectangular form. Rectangular form. Similarly, we will do this for 20 at an angle minus 30 degree. So 20 at an angle minus 30 degree. So again this will be r in bracket cos phi plus j sin phi. So r is 20 here and cos phi value is minus 30 degree. So minus 30 degree plus j sin 30 degree, minus 30 degree. So let's solve this in calculator again. So 20 in bracket cos minus 30 plus I sin minus 30 degree. So it is 17.32, 17.32 minus j10. Again this is the rectangular form. Rectangular form. Now we will add these two. So we get 40 at an angle 50 degree plus 20 at an angle minus 30 degree. So let's copy it from here, the inside part. So it is equal to this value. So let's copy it again. It is for 40 at an angle 50 degree. So for 40 at an angle 50 degree, then this plus sign, then for 20 at an angle minus 30 degree, it is this value in rectangular form. Now to calculate this, first we have to add the real part. So real part here is 25.71. So 25.71 and plus 25.71 plus 17.32, 17.32. So it is 43.03, 43.03 plus j. Now here if we add this imaginary part, so it will be 30.64, 30.64 minus 10. So minus 10, so it is 20.64. So 20.64. Again this is in rectangular form. Rectangular form. What we will do, we will convert this into rectangular form, rectangular form into polar form, rectangular form to polar form. So we need r at an angle phi and it is equal to under root of x square plus y square at an angle tan inverse of y by x. Now here we can see this is this is x and this is y. This is the real part and this is the imaginary part. So let's put it here. So it will be under root of 43.03 square, 43.03 square plus 20.64 square, 20.64 square at an angle tan inverse of y by x. Y value is 20.64 divided by 43.03. 43.03. So if we solve this in calculator directly, we get under root of 43.03 square plus 20.64 square. So it is 47.72. 47.72 at an angle tan inverse of, so tan inverse of 20.64 divided by 43.03, so it is 25.62, 25.62 degree. So this is in polar form. So this is in polar form. This is called as polar form. Now we got the inside answer, but now we have to do the power 1 by 2 of this value. So let's solve this. It will be 47.72 at an angle 25.62 to the power 1 by 2. Now it is equal to, this will be 47.72, 47.72 divided by, not divided by, under root of this at an angle 25.62 divided by 2. So this is how we solve this in polar form. So let's solve this. So under root of 47.72, 47.72, it is 6.90, 6.90 at an angle 25.62 divided by 2. It is 12.81, 12.81. So this is the final answer for this question. Let's copy it from here. Let's copy it from here and paste it here. So this will be the complete solution for this question. Don't forget to share to this video, and thanks for watching. If you are interested in trading, then check the links in the description and sign up now. In this video, we will see Phasors. Question: evaluate these complex numbers. So this is a example on Phasors. We have to simplify this complex number. Solution: first of all, we will write what is given. Now here in the numerator, we have to do the addition, and we know that addition and subtraction, here we can write addition and subtraction are better performed in rectangular form. In rectangular form. So what we will do, we will convert this polar form into its equivalent rectangular form. So convert polar form to rectangular form. Rectangular form. So here this is the polar form. So it is 10 at an angle minus 30 degree, and its equivalent rectangular form will be, so first of all let's see how we can convert polar form to rectangular form. So if r at an angle phi is given, then its equivalent rectangular form will be r in bracket cos phi plus j sin phi. This is called polar form, and this is called rectangular form. So it is 10 at an angle minus 30 degree. 10 at an angle minus 30 degree, it is equal to r. The value of r is 10 cos phi. The value of phi is minus 30 degree plus j sin minus 30 degree. So it is equal to, we can solve this in calculator directly. Let's put the calculator in complex mode. So it is already in complex mode. So 10 in bracket cos minus 30, then plus I into sin minus 30. So it is 8.66 minus 5 or minus j5. So this is the rectangular form. So let's put it here. Let's copy this whole, and in place of this 10 at an angle, in place of this 10 at an angle minus 30 degree, we will substitute this value. So it will be 8.66 minus j5 plus 8.66 minus j5 plus 3 minus j4 divided by this value. It is 2 plus j4, and it is 3 minus j5. It is a complex conjugate. So what we can do, we can change the sign of this imaginary part. So it will be plus 3 plus j5. Now we will simplify this part. So it will be 8.66 plus 3. So it will be 11.66, and here it is minus 4, minus 5 and minus 4. So it is the imaginary part. So this will be minus j9 divided by, now here it is in rectangular form. It is 2 plus j4 and 3 plus j5, and we know that multiplication and division are better performed in polar form. So what we will do, we will convert this rectangular form to its equivalent polar form. So let's convert this 2 plus j4. First we will write the rectangular form, that is x plus jy is equal to now this will be under root of x square plus y square at an angle tan inverse of y by x. So this is the rectangular form, and this will be the equivalent polar form. So let's put it 2 plus j4, 2 plus j4, it is equal to under root of 2 square plus 4 square at an angle tan inverse of 4 by 2. So if we solve this, it will be under root of 2 square plus 4 square. It is 4.47. 4.47 at an angle tan inverse of 4 by 2. So it is 63.43. 63.43 degree. We will do the same for this 3 plus j5. 3 plus j5. So it will be under root of 3 square plus 5 square at an angle tan inverse of 5 by 3. So this will be under root of 3 square plus 5 square. So it is 5.83. 5.83 at an angle tan inverse of 5 by 3. So it is 59.03. 59.03. Now we will replace this rectangular form to polar form. So let's copy it. And now we will change the denominator part. So it will be 11.66 minus j9 divided by, now in place of this 2 plus j4, we can substitute this value. So let's copy it from here. And in place of this 3 plus j5, we can substitute 5.83 at an angle 59.03. 59.03. Now we can simplify it. So it will be 11.66 minus j9 as it is divided by, now we can multiply this 4.47 into 5.83. 4.47 into 5.83. So this will be 26.06. At an angle, we have to add this 63.43 plus 59.03. So this will be, let's copy this and paste it directly to save the time. Now this will be 63.43 plus 59.03. So it is 122.46. Now the numerator is in rectangular form and the denominator is in polar form. Now here we have to perform the division, and we know that multiplication and division are better performed in polar form. So what we will do, we will convert the numerator part which is in rectangular form. So we will convert this rectangular form to polar form. So convert rectangular form to polar form. Rectangular form to polar form, it is 11.66 minus j9. So it will be under root of 11.66 square plus in bracket minus 9 square at an angle tan inverse of minus 9 divided by 11.66. So this will be under root of 11.66 square plus in bracket minus 9 square. So it is 14.72 at an angle tan inverse of minus 9 divided by 11.66. So it is minus 37.66 minus 37.66 degree. So now we can replace the numerator into this polar form. So let's replace it. Let's copy this first. So it will be 14.72 in place of this 11.66 minus J9. We can substitute this 14.72 at an angle minus 37.66 degree divided by 26.06 at an angle 122.46. So let's simplify it. So it will be 14.72 divided by 26.06. So it is 0.564. 0.564 at an angle. Now we have to subtract it. Minus 37.66 minus 122.46. So it is 0.564 at an angle minus 37.66 minus 122.46. So it is minus 160.12 degree. So this is the answer for this question, and it is in the answer is in polar form. So this is the final answer. This is how we can solve complex numbers of phasors. Don't forget to share to this video, and thanks for watching. If you are interested in trading, then check the link in the description and sign up now. In this video, we will see an example on phasors. Question: evaluate these complex numbers. We have to simplify this complex number. So first of all, let's copy this. Now here we can see this is in rectangular form. This is also in rectangular form, and here this is in polar form, and whole of this is the complex conjugate. So first of all, what we will do, here we can see here it is the multiplication. So we know that multiplication, let's write it, multiplication and division are better performed in polar form. And addition and subtraction are better performed in rectangular form. So here we can see, here we have to multiply this. So what we will do, we will convert this rectangular form to polar form. So first convert rectangular form to polar form. So let's convert this 5 plus j2. 5 plus j2. Currently it is in rectangular form. So in polar form this will be under root of 5 square plus 2 square at an angle tan inverse of 2 by 5. 2 by 5. So this will be under root of 5 square plus 2 square. It is 5.38. So 5.38 at an angle tan inverse of 2 by 5. So it is 21.80 degree. Now here we can see this is x and this is y. Here this is r and this is phi. So the formula is something like this: x plus jy is equal to under root of x square plus y square at an angle tan inverse of y by x, and this is called as r at an angle phi. This is the polar form. This is polar form, and this is called rectangular form. Rectangular form. So we will do the same for this -1 plus j4. -1 plus j4. So this will be under root of x square, that is -1 square plus 4 square. 4 square at an angle tan inverse of 4 by -1. So if we solve this, or if we simplify this, so it will be under root of 1 square -1 square. So both are same actually. So let's take -1 square, then plus 4 square. -1 square plus 4 square. So it is 4.123. 4.123 at an angle tan inverse of 4 by -1. So it is -75.96. -75.96 degree. So again this is in polar form. Now let's solve this. So let's copy this from here. Now it is equal to, or here we can write, it is equal to, in square bracket, in place of this 5 plus j2, this is in rectangular form, its equivalent polar form is this 5.38. So 5.38 at an angle 21.80. 21.80. Now similarly for this -1 plus j4, -1 plus j4, it is equal to 4.123 at an angle -75.96 minus 5 at an angle 60 degree, and whole of this complex conjugate. So let's simplify this. So it will be again square bracket as it is. It will be 5.38 multiplied with 4.123. So let's solve it. 5.38 into 4.123. So it is 22.18. 22.18 at an angle this will be 21.80, then plus in bracket minus 75.96. So it is minus 54.16 minus 54.16 minus 5 at an angle 60 degree, and whole of this is complex conjugate, and we already know that here we have to subtract this, and we already know that addition and subtraction are better performed in rectangular form. So now what we will do, we will convert this both polar form to its equivalent rectangular form. So let's convert rectangular form to polar form. So this will be 22.18 at an angle minus 54.16. So this will be r in bracket cos phi plus j sin phi. So here the value of r is 22.18. So 22.18 in bracket cos, the value of phi is minus 54.16 plus j sin minus 54.16. 22.18 in bracket cos minus 54.16. Here also it is minus 54.16. So this will be, we can solve this in calculator directly. So 22.18 in bracket cos minus 54.16 plus I sin minus 54.16. So it is 12.98 minus j 17.98. So this is the rectangular form of this much value. Now we will do the same for 5 at an angle 60 degree. So 5 at an angle 60 degree. So let's simplify it like this: r cos phi plus j sin phi. R cos phi in bracket plus j sin phi, bracket close here. The value of r is 5, cos phi is 60 degree, then plus j sin 60 degree. So now this will be 5 in bracket cos 60 plus I sin 60. So it is 2.5 plus j 2.5 plus j 4.33. Now again let's copy this, and now again square bracket. Now in place of this 22.18 minus 22.18 at an angle minus 54.16, we can substitute this value 12.98 minus j 17.98 minus j 17.98. Now for this 5 at an angle 60 degree, so this minus as it is first, then here this will be in bracket now. So 2.5 plus j 4.33, 2.5 plus j 4.33, bracket close, and here the square bracket close and complex conjugate of this value. Now we can easily simplify this. So this will be 12.98 minus 2.5, real part first. So 12.98 minus 2.5 is 10.48. So let's take square bracket of this, and it is 10.48. 10.48. Now the imaginary part, so it is minus 17.98, minus 17.98. Then again, if this minus goes inside, so it will be minus 4.33. So it is minus 22.31. So minus j 22.31 and square bracket close here, and complex conjugate of this value. Now we have to do the complex conjugate of this. So what we have to do? We have to change this sign. So it will be 10.48. Now here we have to change the sign of imaginary part. So here it is minus. So here this will be plus j 22.31. So this is the complex conjugate of this value. Now this answer is in rectangular form. We can convert this into polar form. So it will be under root of 10.48 square plus 22.31 square at an angle tan inverse of 22.31 divided by 10.48. So this will be under root of 10.48 square plus 22.31 square. So it is 24.64. 24.64 at an angle tan inverse of 22.31 divided by 10.48. So it is 64.83. 64.83. So this answer is in polar form, and this answer is in rectangular form. Rectangular form. So after verifying the answer, we did a little mistake here. So that's why this answer is wrong actually. We can verify the answer. So here we can see it is the answer is actually wrong because we did one mistake there. So it will be 5 plus I into 2 bracket, then minus 1, then plus I 4, then minus 5 at an angle 60, and then we have to take the complex conjugate of this, so we can take it manually. So the answer should be minus 15.5. So here the answer is 10.48, and the answer should be minus 15.5 plus, instead of this plus it should be minus because we have to take the complex conjugate of this. So minus 13.66, but here we are getting 22.31, which is totally different. So after analyzing this, I have found that the mistake we did is here. So here the real part is negative. So that's why what we have to do, we have to add, not add actually, we have to subtract 180 degree to it, or not 180 degree. If we check the answer in calculator, so it will be something like this: minus 1 plus I4, then shift to 3, so it is 4.123, which is correct, at an angle. Here the angle is 104.03 and here the angle is minus 75.96. So what we have to do, if we add 180 degree here, then what will be the answer? So let's add 180 degree here, 180 degree. So this answer will be minus 75.96 plus 180 degree. The answer should be 104.04. So here what we have to do, we have to add 180 degree. So note this. Now we will do the changes accordingly. So here this will be changed to 4.123 at an angle 104. So it will be 104. Again, let's verify the answer. Minus 1 plus I into 4. Then shift to 3. So this is the answer, 4.123 at an angle 104.03. We can skip that. So this should be the answer for this. Now next, what we will do, we will replace this minus 75.96. So let's replace it with this 104. Then let's replace this value also, it will be changed. So this will be now 21.80, 21.80, then plus 104. So now this will be 125.8. So let's write 125.8. And now here also this will be changed to 125.8. 125.8. Also this will be changed to 125.8. Also this will be changed to 125.8. 125.8. So this answer will also change. So let's erase this and let's again calculate this. So it will be 22.18 in bracket cos 125.8 in one bracket, then plus I into sine 125.8, bracket close. So it is equal to this value, minus 12.97, minus 12.97, then plus 17.98, which is approximately equal to 18, or let's write this value as it is. So plus j 17.98, 17.98. Now this value is changed. So here this value will also change. This was actually, instead of minus 54, it was 125.8. 125.8, and the answer for this is changed. So it is minus 12.97, minus 12.97 plus j 17.98, plus j 17.98. This value as it is because it is correct. Then now if we simplify this, so this answer will change, also this answer will be changed. So now this will be minus 12.97, minus 12.97, and this will be minus 2.5. So it is minus 15.47, minus 15.47, and now the imaginary part will be 17.98. So 17.98 minus 4.33. So it is 13.65. So here we can write plus j 13.65, 13.65, and now we have to take the complex conjugate of this value. So this will be this minus 15.47 is the real part, and for complex conjugate we have to change the sign of this imaginary part. So it will be minus j 13.65. So this is the rectangular form. We can skip this polar form. We can write the answer in rectangular form only, or we can also calculate the polar form too if we want. Now let's verify the answer. So it is in bracket 5 plus I into 2, then in another bracket it is minus 1 plus I into 4, then minus 5 at an angle 60. Then we have to take the complex conjugate of this manually. So it is minus 15.5. So here we can see the answer is correct, minus 15.5, which is approximately equal to minus 15.47, and then complex conjugate of this value will be minus. So here also it is minus, then 13.66. So here it is 13.65. So our answer is correct. And also remember that the mistake was here. Here we have to add 180 degree when the real part is negative. So because of this mistake the answer was wrong early, but now the answer is correct. Thanks for watching, and don't forget to share to this video. In this video we will see an example on phasors. Question is, evaluate the complex number. We have to simplify this. Solution. First of all, we will copy this. Now here we can see, first we will do the division. So here it is in rectangular form and it is in polar form. So before doing division we have to do the addition of this, and we know that addition and subtraction are better performed in rectangular form and division and multiplication are better performed in polar form are at an angle phi. This is called as polar form. This is called polar form. And x plus jy, this is called rectangular form. The formulas to convert from polar form to rectangular form is r at an angle phi is equal to r in bracket cos phi plus j sin phi. This formula is to convert polar to rectangular form. And the another formula is x plus jy. So to convert this rectangular to polar form, the formula is x square plus y square at an angle tan inverse of y by x. So this formula is to convert rectangular to polar form. So here we can see, first we will solve the numerator of this. So we will convert this 3 at an angle 40 degree. So 3 at an angle 40 degree into its equivalent rectangular form. So it will be 3 in bracket cos 40 plus j sin 40. So this will be 3 in bracket cos 40 plus I into sin 40. So it is 2.29, then plus j 1.92. Now this is the rectangular form. So let's put it here. So let's copy this again. And before this, or let's simplify this first. So it will be, it is equal to, now in place of this 10 plus j5, it will be same 10 plus j5 as it is. Then plus, in place of this 3 at an angle 40 degree, we can substitute this value 2.29 plus j 1.92 divided by minus 3 plus j4 plus 10 at an angle 30 degree plus j5. So here we have to add the real parts. So it will be 10 plus 2.29. So it will be 12.29, and this will be 5 plus 1.92. These are the imaginary parts. So it will be plus j 6.92 divided by minus 3 plus j4. So plus, now here it is in polar form. So its equivalent rectangular form will be 10 in bracket cos phi plus j. Now in place of this phi, the value of phi is 30 degree. So plus j sin 30 plus j 5. Now let's simplify this. So it will be 12.29 plus j 6.92 divided by minus 3 plus j4 plus, now this will be 10 in bracket cos 30 plus I into sin 30. So it is 8.66 plus j5, then plus j5, this j5. Now this will be simplified as 12.29 plus j 6.92 divided by minus 3 plus j4. Now here this is the real part, so it is 8.66 and this will be plus j10. Now here we already know that division and multiplication are better performed in polar form. So now what we will do, we will convert this rectangular form to polar form. So this will be under root of this value 12.29 square plus 6.92 square divided by, before that at an angle, tan inverse of 6.92 divided by 12.29 divided by, now similarly we will do this for this value. So this will be under root of minus 3 square plus 4 square at an angle tan inverse of this value 4 by minus 3, and with this we have to add plus 180 degree because here the real part is negative, so we have to add 180 degree to it, otherwise our answer will be wrong. And this is separate, so this will be plus this 8.66 plus j10. Now this will be, let's solve this. First we will solve the numerator part, so it will be under root of 12.29 square plus 6.92 square, so it is 14.10 at an angle tan inverse of 6.92 divided by 12.29 is 29.38 divided by, it is under root of minus 3 square plus 4 square, so it is 5 at an angle tan inverse of 4 by minus 3, then plus 180 degree, or we can add separately. So this is the answer, then we have to add 180 degree to it, so it is 126.86, then plus 8.66 plus j10. Now here this will be 14.10 divided by 5, 14.10 divided by 5, so it is 2.82 at an angle. Now we have to subtract this, so it will be 29.38 minus 126.86, then this plus 8.66 plus j10, so this will be 2.82 at an angle. Now if we solve this, so it will be 29.38 minus 126.86, so it is minus 97.48 plus 8.66 plus j10. Again this is in polar form, so we have to do the addition here. So we will convert this polar form to rectangular form, so it will be 2.82 in bracket cos minus 97.48 plus j sin minus 97.48 0.48 bracket close plus 8.66 plus J10. So this will be 2.82 in bracket cos minus 97.48 plus I into sin minus 97.48. So it is minus 0.36 minus 0.367 minus J 2.796 plus 8.66 plus J10. Now here we have to add the real parts. So it will be 8.66 and here this is minus 0.367. So 8.66 minus 0.367. So it is 8.293 and this will be minus 2.796 minus 2.796 and this is plus 10. So it is 7.204. 7.204. So this is the final answer and it is in rectangular form. So this is the final answer for this question. Don't forget to share to this video and thanks for watching. In this video we will see an example on phasors. Question: transform these sinusoids to phasors. Here it is given in sinusoidal form or sinusoids form and we have to convert this current and voltage into its equivalent phasors. So solution for this will be, currently it is given in time domain format. So its solution will be magnitude of I is equal to 6, which is the amplitude or maximum current at an angle. Now here the angle will be, here we can see the value of phi is minus 40 degree. So this is the answer for this A. But for this B, why we have taken this directly? Because it is in cosine form, positive cosine form. But here for this question B or voltage, it is given in minus sine form. So first of all we have to convert this into positive cosine. So let's see how we can convert minus sine into positive cosine. So let's copy this. Let's go to the basics for this. So here on this horizontal axis, this is positive cos omega t. This is minus cos omega t. This is plus sin omega t. And this is minus sin omega t. Now we want to convert minus sin into this minus sin into plus cos. So if we go from here to here, the phasor rotate in this direction. So it is the direction of rotation. Now we are going from here to here. So here the angle difference is 90 degree. That means here we can write minus sin omega t is equal to cos omega t plus 90 degree. Cos omega t plus 90 degree. So here for this question, here it is minus sin minus 4 sin. So this will be small v is equal to, this is the solution for this question. So it will be 4 cos 30t plus 50 degree. Now here what we have to do? We have to add 90 degree to it because we change this from minus sign to plus cosine. So this will be now 4 cos V is equal to 4 cos 30t, and this will be plus 140 degree. So in phasor form, this will be magnitude of V, that is capital V, and this will be 4 at an angle 140 degree. So this is the final answer for this question, and it is in phasor form. Here the value of omega is 30, and here the value of omega is 50 radian per second. So this is how we can transform these phasors, we can transform these sinusoids to phasors. Don't forget to share to this video, and thanks for watching. In this video, we will see an example on phasors. Question: express these sinusoids as phasors. So here, these are the sinusoids. This is a voltage and this is a current, and it is given in time domain format. We have to convert it into phasor domain format, or it is also called as frequency domain format. So solution for this will be, first of all, we will solve this, and its solution will be, here this will be magnitude of this voltage V. So capital V is equal to 7, it is the maximum voltage Vm at an angle phi. So the value of phi phase angle is 40 degree. So this will be 40 degree, and it is already in cosine form, so we can directly take these values because it is in positive cosine form. And here the value of omega is 2 radian per second, and the unit of this voltage will be volts. So this is the final answer for first question. And for second question, let's copy this. Here first we need to convert this negative sign into positive cosine like this. After that we can convert this time domain into its equivalent phasor domain format. So first of all, let's go to the basics. So solution for this will be, this horizontal axis is plus cos omega t, and this is minus cos omega t. This is plus sin omega t, and this is minus sin omega t. Now here we have to convert minus sin omega t into plus cos omega t. So if we go from here to here, the angle difference is 90 degree. So it is plus 90 degree. So what we have to do, the formula will be something like this: cos omega t plus 90 degree, it is equal to minus sin omega t, minus sin omega t. So let's put this value, that is, we will replace this minus sign by cos, and we have to add 90 degree to it. So therefore I is equal to 4, then cos, then 10t plus 10, and we have to add 90 degree to it. So plus 90 degree, and this is current, so its unit is ampere. Now we can easily convert this. So we can further simplify this first. So 4 cos 10t plus 100 ampere. Now its equivalent phasor domain format will be, magnitude of this current is capital I is equal to 4 at an angle, here the angle is 100 degree, and its unit will be ampere. Here the omega value is 10 radian per second. So this is how we can convert sinusoids into its equivalent phasors. Don't forget to share to this video. Thanks for watching. In this video, we will see an example on phasors. Question: find the sinusoids represented by these phasors. So here, first question is I is equal to minus 3 plus J4 ampere. So this phasor is given in rectangular form. So let's copy this. Now we have to convert it into its equivalent sinusoid. So this will be, the solution for this will be I of t is equal to, now before converting this into time domain format, first we need to convert this into its equivalent polar form. So this is the rectangular form, So convert it into polar form, convert it into its equivalent polar form. So this will be I is equal to under root of x square, that is minus 3 square plus 4 square at an angle tan inverse of y by x. So the value of y is 4 divided by minus 3. Here we can see the real part is negative. So what we have to do here, we have to add 180 degree to it, because here the real part is negative. That time we add 180 degree. So now if we simplify this, so it will be under root of minus 3 square then plus 4 square, it is 5 at an angle tan inverse of 4 by minus 3. Now here we have to add 180 degree to it. So plus 180 degree, it is 126.86, 126.86 degree, and ampere. This is the value of current I in phasors in polar form. So this is the polar form of phasor. We have to convert it into its equivalent time domain format. So I of t is equal to, this will be 5 cos omega t plus 126.86 degree, and since it is current, so its unit will be ampere. Now next is this phasor is given in exponential form. So let's copy this first, and now here we can see V is equal to this j multiplied with 8 e to the power minus j 20 degree. So first we know that j is equal to 1 at an angle 90 degree. So this is different, and here this 8 e to the power minus j 20, this is different. So it will be like this. V is equal to, if we convert this exponential form, it is the exponential form, we can write exponential form. We will convert this into its equivalent polar form. So in place of j, we can substitute 1 at an angle 90 degree multiplied with, now this will be 8 at an angle minus 20 degree. So let's simplify this. So it will be 1 into 8, and this will be at an angle 90 degree plus minus 20 degree. So this will be 8 at an angle 70 degree. This is the voltage, so its unit will be volts. Now we will convert this into time domain format, or we have to convert it into its equivalent sinusoids. So it will be V of t is equal to 8 cos omega t plus 70 degree. So this is how we can convert phasor domain into its equivalent sinusoids. Don't forget to share to this video, and thanks for watching. In this video, we will see an example on phasors. Question: find the sinusoids corresponding to these phasors. So here the voltage phasor is given, also the current phasor is given. It is in this voltage phasor is in polar form, and here this current phasor is in rectangular form. So first of all, let's solve this first question or first phasor. So let's write it here. Now solution for this will be, here it is in polar form, it is the polar form. So what we will do, we have to find sinusoids corresponding to these phasors. So we have to find v of t, and this will be, here the value of amplitude is minus 10. So this will be minus 10 as it is. Then cos omega t, cos omega t plus 30 degree. Now here we can see it is in minus, so we need to convert this minus to plus. Let's go to the basics. So here this is plus cos omega t on this horizontal axis, and here this is minus cos omega t. This is plus sin omega t, and this is minus sin omega t. The phasor rotate in this direction. So we want to convert this minus cos into plus cos. So here is the minus cos omega t, we have to change it into plus cos omega t. So we can move in this direction like this. So the difference is 180 degree. So it is plus 180 degree, because if we move from here to here in this direction, so we have to add 180 degree. And if we move in opposite direction, this is also correct, but this direction is opposite, so we have to subtract 180 degree. So both are correct. So here we can write cos omega t plus 180 degree is equal to minus cos omega t, and also cos omega t minus 180 degree is equal to minus cos omega t. So minus 180 degree is equal to minus cos omega t, both are correct. Now we have to change this minus sign. So what we will do, this will be v of t is equal to 10 cos omega t plus 30 degree. So it is as it is. Then we have to add 180 degree. So this will be plus 180 degree. So this will be v of t is equal to 10 cos omega t plus this will be 210 degree. So this is the answer in time domain format, or it is in sinusoids form. Now second question, we have to convert this phasor into its equivalent sinusoids. So let's paste the question. Now here it is given in rectangular form, and we know that j is equal to, this is the solution. So j is equal to 1 at an angle 90 degree, and here this is 5 minus j12. So 5 minus j12 is equal to, this is in rectangular form. In polar form, this will be under root of 5 square plus minus 12 square at an angle tan inverse of y by x. The value of y is minus 12 divided by 5. So this will be under root of 5 square plus in bracket minus 12 square. So it is 13 at an angle tan inverse of minus 12 by 5. So minus 12 divided by 5, that is minus 67.38. Minus 67.38 degree. Minus 67.38 degree. Now let's multiply it. So here first we will write this 5 minus j12. Now in place of this j we can substitute 1 at an angle 90 degree. So let's substitute it. I is equal to in bracket 1 at an angle 90 degree, and in place of this 5 minus j12 we can substitute this value 13 at an angle minus 67.38 degree. Now why we change from this rectangular form to this polar form? Because multiplication and division are better performed in polar form, and this is the polar form of this both. Now we can easily multiply it. So this will be I is equal to 1 into 13 at an angle. Now this will be added. So 19 degree plus minus 67.38. Minus 67.38. So this will be I is equal to 13 at an angle 90 plus in bracket minus 67.38. So this will be 22.62. 22.62 degree. Since it is current, so its unit will be ampere. Now its time domain format will be I of t is equal to 13 cos omega t plus 22.62 degree ampere. So this is the I of t in time domain format. So this is how we can solve sinusoids corresponding to these phasors. That means this is how we can convert phasors into its equivalent sinusoids. Don't forget to share to this video, and thanks for watching. If you want more videos like this, then subscribe to this channel. In this video, we will see an example on phasors. We have to do addition of these two sinusoids by using phasors. Question: given I1 of t is equal to 4 cos omega t plus 30 degree ampere and I2 of t is equal to 5 sin omega t minus 20 degree ampere. Find their sum. So first of all, we will write what is given. So I1 of t is equal to 4 cos omega t plus 30 degree ampere, and I2 of t. Before writing I2 of t, here we can see it is given in standard form. So we can easily convert this time domain format into its equivalent phasor domain format. So I is equal to 4, this 4 at an angle. Here the angle phi is 30 degree. So this is the phasor in polar form. So polar form. Now we will write this I2. Also it is I1, so this will be capital I1. Now we will write this I2. I2 of t is equal to 5 sin omega t minus 20 degree ampere. Now here we can see we have to convert this sine into cosine form first, and after that we have to convert time domain format into its equivalent phasor domain format, and it is also called as Phasor domain is also called as frequency domain format. So let's convert this sine into cosine. So to convert sine to cosine, let's go to the basics. So here this is plus cos omega t and this is minus cos omega t. This is plus sine omega t and this is minus sine omega t. We have to convert plus sine omega t into cos omega t. So we are going from here to here like this, and the direction of rotation of phasor is this. So if we go in this direction, that time it will be positive, but currently we are going in opposite direction, so we have to subtract minus 90 degree. Why 90 degree? Because the angle is of 90 degree. So it will be, the formula will be like this: cos omega t minus 90 degree is equal to sin omega t. Now we can change this sin to cos by subtracting 90 degree. So it will be I2 of t is equal to 5 cos omega t minus 20 degree as it is, omega t minus 20 degree as it is. Then we have to subtract 90 degree and ampere as it is, because it is current, so its unit will be ampere. Now let's simplify it. So 5 cos omega t, and here this will be minus 20 minus 90 degree, so this will be minus 110 degree ampere. Now it is in standard form. Now we can easily convert this time domain format into its equivalent phasor domain. So I2 is equal to 5 at an angle minus 110 degree ampere. So this is the value of I2, and here this is the value of I1. Let's say this is equation number 1 and let's say this is equation number 2. So therefore I1 plus I2 is equal to 4 at an angle 30 degree, 4 at an angle 30 degree plus 5 at an angle minus 110 degree. Now this is given in polar form, also this is given in polar form, and we know that here we have to do addition, and we know that addition and subtraction are better performed in rectangular form. So what is rectangular form and what is polar form? So r at an angle phi, z is equal to r at an angle phi, this is called as polar form, and z is equal to x plus jy, this is called as rectangular form. Now we have to convert this polar form to rectangular form, these two polar form into its equivalent rectangular form. So the formula is like this: r at an angle phi is equal to r in bracket cos phi plus j sin phi. So here the value of r is, first we will convert this 4 at an angle 30 degree. So 4 at an angle 30 degree is equal to r value is 4 in bracket cos phi. The value of phi is 30 degree plus j sin 30 degree. So therefore this will be 4 at an angle 30 degree. So 4 in bracket cos 30 plus I into sin 30. So it is 3.46 then plus J2, plus J2. Now we will do the same for phi at an angle minus 110 degree. Phi at an angle minus 110 degree, it is equal to phi cos minus 110 degree plus j sin minus 110 degree. So this will be phi in bracket cos minus 110 degree plus I into sin minus 110 degree. So it is minus 1.71 minus 1.71 minus j 4.69. So phi at an angle minus 110 degree. Now we got both the polar form into its equivalent rectangular form. So therefore I1 plus I2 is equal to, we can substitute I1 plus I2 is equal to this value. In place of 4 at an angle 30 degree, we will substitute this value. Let's say this is equation A and this is equation number B. So 3.46 plus J2, then we have to do the addition, but here it is minus, so directly we can substitute minus 1.71 minus J 4.69. So this will be 3.46 minus 1.71. 3.46 minus 1.71. So this will be 1.75, 1.75, and this will be 2 minus 4.69. So it is minus j 2.69. First we have to solve the real part and then we have to solve the imaginary part. So this is the final answer for I1 plus I2 in rectangular form. This is called as rectangular form, but we need the answer in, we have to add these two sinusoids and get the sum of them. So let's convert this into its equivalent polar form again. So convert it into polar form. So this will be 1.75 minus j 2.69 and it is equal to under root of x square, that is 1.75 square plus minus 2.69 square at an angle tan inverse of minus 2.69 divided by 1.75. So if we solve this, we get under root of 1.75 square plus in bracket minus 2.69 minus 2.69 square. So it is 3.209 at an angle. Now here this will be tan inverse of minus 2.69 divided by 1.75. So it is minus 56.95 degree, and this is in polar form of phasor. So therefore here we can write this is I1 plus I2 in polar form. Now we can convert it into its equivalent time domain format. So it will be I1 of t plus this will be I2 of t is equal to 3.209 cos omega t minus 56.95 degree, and since it is current, so its unit will be ampere. Also here we can check the value of omega is unknown, so we can substitute omega as omega. So this is how we can add sinusoids by using phasors. Don't forget to like, share and subscribe to this channel. Thanks for watching. In this video, we will see an example on phasors. Question: if V1 is equal to minus 10 sin omega t minus 30 degree volt and V2 is equal to 20 cos omega t plus 45 degree volt, we have to find the addition of these two, that is V is equal to V1 plus V2. So solution for this will be, first of all we will write what is given. So let's copy it directly from here. So this is the value of V1. Now here we can see, here it is given in minus sign form. So first of all we need to convert this into its standard form, and the standard form is, here we have to replace this minus sign by plus cosine. So let's go to the basics, how we can convert minus sign into plus cosine. So here this is plus cos omega t and this is minus cos omega t. This is plus sin omega t and this is minus sin omega t, and phasor rotate in this direction. So here it is minus sign, that is minus sin omega t, and we need to convert this into cos omega t. So we have to move from here to here, and the angle difference is 90 degree and we are rotating in counterclockwise direction. That means we have to add 90 degree. That means the formula will be cos omega t, or let's write sin minus sin omega t first. So the formula will be minus sin omega t is equal to cos omega t plus 90 degree plus 90 degree. So let's substitute. In place of this minus sign, we can substitute this value cos omega t plus 90 degree. So it will be V1 is equal to this 10 as it is. Now in place of this minus sign, we can substitute cos omega t plus 90 degree. So cos this omega t minus 30 degree as it is, just we have to add 90 degree to it, and since it is a voltage, so its unit will be volts. Now let's simplify this. So V1 is equal to 10 cos in bracket omega t, and this will be plus 60 degree volt. Now this is the standard form and it is given in time domain format. So we have to convert it into its equivalent phasor domain format. So therefore capital V1 is equal to 10 at an angle 60 degree, and this is called as polar form of phasor, and this is given in time domain format. Now we will do the same for V2. So let's copy it. Now here we can clearly see the V2 is given in standard format, so we don't need to change anything, just we can directly convert this time domain format into its equivalent phasor domain format. So this will be capital V2 is equal to 20 at an angle 45 degree. Since it is a voltage, so its unit will be volts. Here also the unit will be volts. It will be volts here, and this is called as polar form. Now what we have to do? We have to add V1 plus V2. So capital V1 plus capital V2 is equal to 10 at an angle 60 degree plus V2 value is 20 at an angle 45 degree. Now it is given in polar form, and we know that here we have to do the addition, and we know that addition and subtraction are better performed in rectangular form, and also remember that multiplication and division are better performed in polar form. So let's convert them. So here this will be 10 at an angle 60 degree. Now here this 10 is R and this 60 degree is phi. The formula to convert polar form to rectangular form is R in bracket cos phi plus j sin phi. Now this will be, the value of R is 10 in bracket cos phi. The value of phi is 60 degree plus j sin phi. The value of phi is again 60 degree. So if we solve this in calculator, so this will be 10 in bracket cos 60 plus I into sin 60. So this will be 5 plus j 8.66, and this is the rectangular form. Now we will do the same for this 20 at an angle 45 degree. 20 at an angle 45 degree. So again the formula will be same. Let's copy it from here. And the value of R is 20 in bracket cos, the value of phi is 45 plus j sin 45, and this will be, now let's solve this in calculator. So 20 in bracket cos 45 plus I into sin 45. So it is 14.14 plus j 14.14. So again this is the rectangular form. Now we can easily add V1 and V2, and we can replace this polar form by its equivalent rectangular form. So therefore capital V1 plus capital V2 is equal to this value, 5 plus j 8.66. So 5 plus j 8.66 plus 14.14 plus j 14.14. Now here we have to add the real parts and then add the imaginary parts. So here the real parts are 5 plus 14.14. So this will be 19.14, then plus j 8.66 plus 14.14. 8.66 then plus 14.14. So it is 22.8. And this is the answer for V1 plus V2, and this answer is in rectangular form. rectangular form, but we need to find the answer in time domain format. So we have to convert this into polar form first. So let's convert this into convert it into polar form. So the formula will be 19.14 plus j 22.8 is equal to, the formula will be like this, under root of x square plus y square at an angle tan inverse of y by x. So here this is x and this is y. So let's substitute the values. So under root of x square is 19.14 square plus y square is 22.8 square at an angle tan inverse of 22.8 divided by 19.14. So now this will be under root of 19.14 square plus 22.8 square. 19.14 square plus 22.8 square. So it is 29.76. 29.76 at an angle. Now this will be tan inverse of 22.8 divided by 19.14. So it is 49.98, which is approximately equal to, we can write 50 here, 50 degree. So this is the answer in polar form for this 19.14 plus j 22.8, which is V1 plus V2. So here this is V1 plus V2 and this is the phasor in polar form. We can write phasors in either polar form or rectangular form. So now we need the answer in time domain format. So therefore V is equal to small v1 plus small v2 is equal to, this will be 29.76 in cos omega t plus 50 degree. So this is the answer in time domain format. So this is how we can add two sinusoids by using phasors. Don't forget to like, share and subscribe to this channel. Thanks for watching. In this video we will see RLC, that is resistor, capacitor and inductor, voltage and current relationship in time domain and in frequency domain, which is also called as phasor domain. So for resistor, voltage is equal to resistance into current. This is in time domain, and we know that for resistor the voltage and current are in phase. Current I is equal to Im cos omega t plus phi, where Im is the maximum current, cos represents that it's a cosine waveform, omega is the angular frequency, t is the time in second, and plus this phi represents phase angle. So this is in time domain format. Now for resistor, the voltage and current relationship in frequency domain or phasor domain format will be capital V is equal to I into R, that is voltage is equal to current into resistance. Now for inductor, inductor is represented by L. So here the voltage and current relationship in time domain is V is equal to L di by dt. And we know that I is equal to Im cos omega t plus phi. So here if we substitute this value of I in here, then we have to do the derivative of this. The derivative of this will be omega, then this will be minus, in place of this cos, this will be minus sine, but here we have written omega, this L as it is, then this Im as it is. Now in place of, it should be minus sign, but we have substituted cos. So what we did, we added 90 degree to it. So this become then the standard equation. So therefore, after simplifying this, the final formula will look something like this. Voltage is equal to omega L Im cos omega t plus phi plus 90 degree. Now in case of inductor, the current lags voltage by 90 degree, or we can say voltage leads current by 90 degree. Here we can see in frequency domain, V is equal to j omega L I. This j represents that voltage leads current by 90 degree. For capacitor, here we can see V is equal to I divided by j omega C. Now if we take this 1 by j, it will be minus j. That means it represents voltage lags current by 90 degree, or we can say it will be current leads voltage by 90 degree. Now let's go to the capacitor for time domain format. So in time domain, current is equal to, this is the relationship between voltage and current for capacitor. So I is equal to C dV by dt, and we know that V is equal to Vm cos omega t plus phi. Now if we substitute this voltage value here, then we have to take the derivative of this. Then after simplifying and adding 90 degree, it will become a standard equation. Now in frequency domain, this will be V is equal to I divided by j omega c. So just remember all of these formulas. Once more, let's revise it. For resistor, V is equal to R into I, that is voltage is equal to resistance into current. This is in time domain format. So this will be smaller, and also this will be, this current I will be in smaller. So I is equal to Im cos omega t plus phi. For resistor, the voltage and current are in phase. For frequency domain, V is equal to I into R. Now for inductor, we know that I is equal to Im cos omega t plus phi, and the voltage and current relationship is given by V is equal to L di by dt. If we substitute this current value here, then we have to take the derivative. If we take derivative, then this will be minus sign form, but if we add plus 90 degree to it, then it will become cos. So the final voltage equation or voltage and current relation will be V is equal to omega L Im cos omega t plus phi plus 90 degree. This is in time domain format, and in frequency domain format, V is equal to j omega L I. For capacitor, in time domain, we know that voltage is equal to V is equal to Vm cos omega t plus phi, and current I is equal to C dV by dt. If we substitute this voltage value here, then we have to take the derivative of this. Again, this cos will become minus sign, but here we have to add 90 degree to it to make it cosine form. So the final current and voltage relationship will be I is equal to omega c Vm cos omega t plus phi plus 90 degree. And for frequency domain, V is equal to I divided by j omega c. So remember all of these formulas. Don't forget to like, share and subscribe to this channel. Thanks for watching. In this video, we will see an example on sinusoids and phasors. Question: find I of t. Here we have to find this I of t. Voltage is given, V of t is equal to 4t cos 60t plus 30 degree. The value of inductance is given, L is equal to 0.2 Henry. We have to find I of t, that is current in time domain format. Solution, first of all we will write what is given. So V of t is given, V of t is equal to 40 cos 60t plus 30 degree. Now first of all what we will do, we will compare this with standard equation. So V of t is equal to Vn cos omega t plus phi. So from this we can say Vm is equal to 40 volts is the maximum voltage or amplitude, omega which is the angular frequency, omega is equal to 60 radian per second, and the value of phi is equal to 30 degree. So here this is phi which is phase angle, it is 30 degree. Also the value of inductance is given, L is equal to 0.2 Henry. So here we can write L is equal to 0.2 Henry, and we have to find I of t is equal to question mark. And we know that for inductor the voltage and current relation is given by, in frequency domain it is given by V is equal to j omega L I. This is in frequency domain. Frequency domain, and it is the V and I relationship. V and I relationship in frequency domain for inductor. Now we can substitute all the values. So here we can see this voltage is given in time domain form, so its equivalent, let's copy this and convert it into phasor domain, which is also called as phasor domain or frequency domain. So this will be capital V is equal to 40 at an angle is 30 degree. Now we got the value of this voltage, then we also have the value of omega and L. So from here we can say I is equal to V, voltage V divided by j omega L. The value of voltage is 40 at an angle 30 degree divided by, now here this j is 1 at an angle 90 degree, and this omega, the value of omega is, here we can see 60 radian per second. So 60 multiplied with the value of inductance, it is 0.2 Henry. So it is 0.2 Henry. Now here this will be 40 at an angle 30 degree divided by, now 1 into 60 into 0.2. So this will be 1 into 60 into 0.2. So it is 12 at an angle 90 degree. Now from this I is equal to 40 divided by 12. So 40 divided by 12, it is 3.33. So 3.33 at an angle 30 degree minus 90 degree. So this is how we solve division of polar form. So therefore I is equal to 3.33 at an angle, this will be minus 60 degree. Now this is the value of current I in phasor form. So it is in phasor domain form. Now I of t, So time domain format, this will be 3.33 cos omega t. The value of omega is 60 radian per second. So it will be 60 t plus, not plus, the value of phi is minus 60 degree. So minus 60 degree. Now this is the value of I of t in time domain format. So this is how, and also remember it is current, so its unit will be ampere. Also here the unit will be ampere. So this is how we can solve, or we can find I of t for inductor. Don't forget to like, share and subscribe to this channel. Thanks for watching. In this video we will see an example on sinusoids and phasors. Question: find I of t. Here for this capacitor we have to find this I of t when voltage V of t is equal to 20 cos 50t plus 40 degree, and the value of capacitor is C is equal to 20 microfarad. So solution: first of all we will write what is given. The value of voltage is given, so V of t is equal to 20 cos 50t plus 40 degree. We will compare this with standard equation. V of t is equal to Vm cos omega t plus phi. Now here we can see Vm is equal to 20. Vm is the maximum voltage and Vm is equal to 20 volts. The value of omega is 50 radian per second, and the value of phi, which is phase angle, phi is equal to 40 degree. Now the value of capacitance is also given. C is equal to 20 microfarad. C is equal to 20 microfarad. We have to find I of t. So I of t is equal to question mark. For capacitor, V is equal to I divided by j omega c. This is the voltage and current relationship in frequency domain. In frequency domain for capacitor. Now here we can see, if we copy this voltage and it is given in time domain format. So first of all let's copy it. It is in time domain representation, and in phasor domain or frequency domain, capital V is equal to this 20 at an angle 40 degree. Because it is given in standard format, so we can directly convert it into its equivalent frequency domain, or it is also called as phasor domain. Now we can substitute the value of this voltage here. So from this equation we can say current I is equal to voltage V multiplied with j omega c, or let's write j first. So j omega c into V. Now here the value of j is 1 at an angle 90 degree. The value of omega is 50 radian per second. So 50 multiplied with C. The value of capacitance is 20 into 10 to the power minus 6. Since it is in microfarad, so it will be 20 into 10 to the power minus 6. 20 into 10 to the power minus 6 into voltage. So the value of voltage is 20 at an angle 40, 20 at an angle 40 degree. So now current I is equal to 1 into 50 into 20 into 10 to the power minus 6 into 20. So 1 into 50 into 20 into 10 to the power minus 6 into 20. So this is 0.02 at an angle. Now this angle and this angle will be added. So it will be 90 degree plus 40 degree. So therefore current I is equal to 0.02 at an angle 130 degree. Since it is current, so its unit will be ampere. So this is the value of current I and it is in frequency domain. Frequency domain, or it is also called as phasor domain. Phasor domain. Now we will convert this into time domain format. So I of t is equal to 0.02 cos omega t. The value of omega is known and it is 50 radian per second. So 50 t plus the value of phi is 130 degree. So 130 degree, and since it is current, so its unit will be ampere. So this is the value of current in time domain. It is in time domain. So this is how we can find the value of current for this capacitor. Don't forget to like, share and subscribe to this channel. Thanks for watching. In this video, we will see an example on sinusoids and phasors. Question: find I of t. We have to find this I of t for this capacitor. Voltage is given as V of t is equal to 20 cos 60t plus 30 degree. The value of capacitance is given, C is equal to 100 microfarad. So first of all, let's write what is given. V of t is equal to 20 cos 60t plus 30 degree. Now since it is a voltage, so its unit will be volts, and also it is given in standard form. Let's write the standard form. V of t is equal to Vm cos omega t plus phi. Now we can compare this. So this Vm, which is the maximum voltage, is equal to 20 volts. This omega, which is angular frequency, it is equal to 60 radian per second. And this phi, which is phase angle, so it is equal to 30 degree. Now the value of capacitance is also given. C is equal to 100 microfarad. C is equal to 100 microfarad, which is equal to 100 into 10 to the power minus 6 farad. Now we have to find this I of t. So I of t is equal to question mark. First of all, let's write this V of t. It is given in time domain format. It is called, let's write it here. It is called as time domain. Time domain representation. Let's convert this into its equivalent phasor domain or frequency domain format. So this V of t will be capital V is equal to 20 at an angle 30 degree. This is called as frequency domain. Frequency domain or phasor domain. Phasor domain. Phasor domain, and it is in polar form. Now what we have to do? We have to find this I of t. And for capacitor, voltage and current relation, in frequency domain is given by, so it is given by V is equal to I divided by j omega c. So this is the relationship between voltage and current. Now we have to find I. So from this we can say I is equal to j omega c V. If we take this on this side, so it will be like this. Now this j is 1 at an angle 90 degree. This omega is angular frequency and it is 60 radian per second. So let's substitute 60 here multiplied with capacitance. The value of capacitance is 100 into 10 to the power minus 6. 100 into 10 to the power minus 6 multiplied with voltage, which is 20 at an angle 30 degree. So 20 at an angle 30 degree. Now let's multiply this. So it will be this 1 multiplied with 60 multiplied with 100 multiplied with 10 to the power minus 6 multiplied with 20. So it is 0.12. 0.12 at an angle. Now these two angles will be added because we are doing multiplication. So 90 degree plus 30 degree. So it will be 0.12 at an angle 120 degree. So this is the value of current I in frequency domain. Let's convert this into time domain format. So I of t is equal to 0.12 cos omega t. The value of omega is 60. So 60 t plus 120 degree. And since it is current, so its unit will be ampere. And this is called as time domain. So let's write it here. It is in time domain format. So this is the final answer for this question. Don't forget to like, share and subscribe to this channel. Thanks for watching. In this video, we will see an example on sinusoids and phasors. Question: the voltage V is equal to 12 cos 60t plus 45 degree is applied to a 0.1 Henry inductor. Find the steady state current through the inductor. Solution: first of all, we will write what is given. So voltage is given in time domain format. So it is V is equal to 12 cos 60t plus 45 degree. Now it is given in time domain format. Time domain format or time domain representation. We can compare this with standard equation. The standard equation is V is equal to Vm cos omega t plus phi. Here it is small v, or we can write V of t. We can also write it like this, V of t or small v. Here also it is V of t or V. Now here we can see Vm is equal to, Vm is the maximum voltage and it is equal to 12. So Vm is equal to 12 volt. This Vm is also called as amplitude. This omega is the angular frequency. Omega is equal to 60 radian per second. And here this phi is the phase angle and it is equal to 45 degree. So phi is equal to 45 degree. Now next, let's convert this time domain into its equivalent frequency domain. So here this will be V of t is equal to 12 cos 60t plus 45 degree. Now in frequency domain this will be capital V is equal to 12 at an angle 45 degree. So this is called as frequency domain format, or it is also called as or phasor domain. Now the value of inductance is given, L is equal to 0.1 Henry. So here we can write L is equal to 0.1 Henry, and what we have to find? We have to find steady state current through inductor. That means we have to find current I of t. Now for inductor, the voltage and current relationship, the voltage and current relationship for inductor in frequency domain is given by capital V is equal to j omega L I. So this is in frequency domain. Now we have to find this I, not this I, this is in frequency domain. We have to find it in time domain format. So first we will find it in frequency domain format. After that we will convert it into its equivalent time domain format. So I is equal to V divided by j omega L. The value of voltage is, here we can see it is 12 at an angle 45 degree. So 12 at an angle 45 degree divided by, now this j is 1 at an angle 90 degree multiplied with omega. The value of omega here is 60 radian per second. So 60 multiplied with L. The value of L or inductance is 0.1 Henry. So 0.1 Henry. Now if we simplify this, so it will be 12 at an angle 45 degree as it is divided by, if we multiply this 1 into 60 into 0.1. So 1 into 60 into 0.1. So it is 6. So this will be 6 at an angle 90 degree as it is. So therefore I is equal to 12 divided by 6. So this will be 2 at an angle 45 degree minus, here we have to do subtraction because we are doing division. So 45 degree minus 90 degree. So this will be I is equal to 2 at an angle minus 45 degree. Now since it is current, so its unit will be ampere. And this answer is in frequency domain format or phasor domain. Now we will convert this into time domain. So I of t is equal to 2 cos omega t. The value of omega is 60. So 60t minus this 45 degree. And since it is current, so its unit will be ampere. So this is the value of current I, and it is in time domain format or time domain representation. Don't forget to like, share and subscribe to this channel. Thanks for watching. In this video, we will see an example on sinusoids and phasors. Question: if voltage V is equal to 10 cos 100t plus 30 degree is applied to a 50 microfarad capacitor, calculate the current through the capacitor. So solution: first of all we will write what is given. So here the value of voltage is given. V is equal to 10 cos 100t plus 30 degree, and since it is a voltage, so its unit will be volts. Now the value of capacitance is given. So C is equal to 50 microfarad, which is equal to 50 into 10 to the power minus 6 farad. We have to calculate the current through the capacitor. That means we have to find this I. Now, if we compare this voltage equation with standard equation, the standard equation is V is equal to Vm cos omega t plus phi, where this Vm is the amplitude or maximum voltage. So here Vm is equal to, here we can see it is 10 volts, omega which is the angular frequency, it is equal to 100 radian per second. So omega is equal to 100 radian per second. Then the value of phi. So phi is equal to 30 degree. Phi is equal to 30 degree. Now currently this equation is in time domain format. So here we can write it is in time domain. So what we will do, we will convert time domain to frequency domain. Time domain to frequency domain. So therefore capital V is equal to, we can write 10 at an angle 30 degree. So it will be 10 at an angle 30 degree, and since it is a voltage, so its unit will be volts. Now for capacitor, we have to solve this we have to find the current through the capacitor. So for capacitor, the voltage and current relation is given by, in frequency domain it is given by V is equal to I divided by j omega c. So from this is the V and I relation, for capacitor in frequency domain. So from this we can say I is equal to j omega c V. Now here this j means 1 at an angle 90 degree into omega. Omega is angular frequency and its value is 100 radian per second. So it is 100 multiplied with C, which is the capacitance, and its value is, here we can see the value of capacitance is 50 into 10 to the power minus 6 farad. 50 into 10 to the power minus 6 farad multiplied with voltage. The value of voltage here is 10 at an angle 30 degree. So it is 10 at an angle 30 degree. Now if we simplify this, so it will be 1 into 100. So let's solve this in calculator. 1 into 100 into 50 into 10 to the power minus 6 into 10. So it is 0.05. 0.05 at an angle. Now the angle will be added here because it is in multiplication. So it will be 90 degree. 90 degree plus 30 degree. So 90 degree plus 30 degree. This will be 0.05 at an angle. This will be 120 degree. And since it is current, so its unit will be ampere. And currently it is in frequency domain. Currently it is in frequency domain format. Now we will convert it into time domain. So this will be small I is equal to 0.05 cos the value of omega. The value of omega is 100. So here this will be 100 t plus 120 degree. 120 degree is the value of phi. And since it is current, so its unit will be ampere. Now this answer is in time domain format. So it is in time domain. So this is how we can find current through capacitor. Don't forget to like, share and subscribe to this channel. And thanks for watching. In this video we will see what is impedance. Impedance is denoted by Z. So first we will write impedance is denoted by Z. Now what is impedance? So impedance is the effective opposition to the flow of alternating current. AC. Impedance is the effective opposition to the flow of alternating current. The unit of impedance is ohm. The unit of impedance is ohm. One more definition for impedance is given by impedance is the ratio of voltage and current. That means Z is equal to V by I. Now here this V is the voltage and this I is the current. And since it is impedance, so its unit will be ohm. Now here we can write in frequency domain, in frequency or phasor domain, voltage and current relation for resistor. So first we will write for resistor V is equal to I into R. This is for resistor. Now if we put this value in this impedance, then from this we can say Z is equal to V by I and if we substitute the value of V here, which is I into R, so this will be I into R divided by I. So this I and this I will get cancelled. So the value of impedance will be only R and its unit will be ohm. So this is for resistor. Impedance is equal to resistance. Now for inductor, the voltage and current relationship for inductor is given by V is equal to j omega L into I. Now if we substitute this voltage value in this equation, that is Z is equal to V by I. The value of voltage is, if we substitute j omega L I, now divided by this I. So this I and this I will get cancelled. So Z is equal to only j omega L. And again its unit will be ohm. Now for capacitor, we know that the voltage and current relationship for capacitor is given by V is equal to I divided by j omega C. So if we substitute Z is equal to V by I, and if we substitute the value of this voltage V, so it will be I divided by j omega C. So I divided by j omega C into this I as it is. So this I and this I will get cancelled. So 1 upon j omega C and its unit will be ohm. Now here it is omega L. So this omega L represents inductive reactance. Inductive reactance, and this 1 upon omega C. So this 1 upon omega C represents capacitive reactance. This inductive reactance, here we can write omega L is equal to, this is the inductive reactance and it is represented by XL. So it is XL and this is called as inductive reactance. Now next is this capacitive reactance, which is 1 upon omega C and it is represented by XC. So it is capacitive reactance. Capacitive reactance is denoted by XC. This X represents reactance and this C represents capacitive. So it is capacitive reactance and this is inductive reactance. And this omega is equal to 2 pi f. So it is 2 pi f and this is 1 upon 2 pi fc, 1 upon j omega c. So this is about impedance. Again let's revise it. Impedance is denoted by Z. Impedance is the effective opposition to the flow of alternating current. The unit of impedance is ohm. Impedance is the ratio of voltage and current. So this is Ohm's law for AC circuit. Z is equal to V by I. In DC circuit, R is equal to V by I. For AC circuit, it is Z is equal to V by I. And the unit of impedance is ohm. In frequency or phasor domain, for resistor, V is equal to I into R. We know that this is the voltage and current relationship for resistor. Now if we substitute Z is equal to V by I, we know the formula for impedance, and if we substitute the value of voltage here for resistor, it is I into R. So it is I into R. So this I and this I will get cancelled. So therefore impedance is equal to R ohm, that is resistance ohm. For resistor the impedance is only resistance, and for inductor we know that the voltage and current relationship is given by V is equal to j omega L I. Now if we substitute this voltage in this equation, Z is equal to V by I, so it will be j omega L I divided by I. So this I and this I will get cancelled. So therefore impedance is equal to j omega L ohm. This omega L represents inductive reactance. Now for capacitor, voltage and current relationship is given by V is equal to I divided by j omega C. And if we substitute Z is equal to V by I, so the value of, if we substitute V is equal to I by j omega C, then this will be I divided by j omega C into I. So this I and this I will get cancelled. So it is equal to 1 upon j omega C. And this 1 upon omega C represents capacitive reactance and its unit is ohm. So again omega L is equal to XL, which is inductive reactance, and 1 upon omega C represents XC, which is capacitive reactance. So this is about impedance. Don't forget to like, share and subscribe to this channel. Thanks for watching. In this video we will see what is admittance. Admittance is the inverse. Admittance is the inverse of impedance. Z. Impedance is denoted by Z. We can say admittance is the inverse of impedance or reciprocal of impedance. Admittance is denoted by Y, and unit of admittance or admittance is measured in Siemens. Admittance is measured in Siemens. So admittance is the reciprocal of impedance, that means it is 1 upon Z. So this is called admittance, which is the reciprocal of impedance. Now we know that Z is equal to, V by I, because impedance Z is the ratio of voltage upon current. So we can rewrite this as I upon V, that is current upon voltage. So therefore admittance is the ratio of current and voltage. Now we know that impedance Z is equal to R plus jX, where this R is the resistance, and this X is reactance. It is reactance. Now if we take the reciprocal of this, or if we write Y, admittance is written like G. So G is conductance, which is the reciprocal of resistance, plus JB. Now this B is the susceptance, which is the reciprocal of reactance. So here we can write 1 upon R is equal to G, which is conductance, and 1 upon X is equal to B, which is susceptance. So here we can write This G is the conductance. This B is the susceptance. Now here, if we substitute in place of Z, we can substitute R plus Jx. So let's substitute it. Y is equal to 1 upon Z. So it will be 1 upon Z. The value of Z is R plus Jx. So R plus Jx. Now if we multiply this with complex conjugate of this, that means R minus Jx, this is the complex conjugate of this, and also divide this by R minus Jx. So this and this will get cancelled. Now if we simplify this, so it will be R minus Jx divided by, now if we multiply this, so it will be a square minus b square. So if we multiply this, so it will be R minus Jx, and this is R plus Jx, and this is R minus Jx. So this formula is a square minus b square. So this will be admittance y is equal to R minus Jx divided by R square minus J square x square. So it will be plus, or we can write J square here, J square x square, and we know that J square is equal to minus 1. We can verify it. I square is equal to minus 1. So this will be R minus Jx divided by R square plus x square. Now if we separate this real part and imaginary part, so this will be admittance y is equal to R divided by R square plus x square. So R square plus x square, then minus jx x divided by R square plus x square. So here this is the real part. This is real part, and this is imaginary part. Imaginary part. This is real part and this is imaginary part. So if we compare this with this equation, let's say this is equation number 1. So this is, let's say this is equation number 2. So compare equation 2 with 1, then we get here, we can see here the real part is G. So here we can write this is the real part, and this B is the imaginary part, So G is equal to, we can write G is equal to R divided by R square plus x square. R square plus x square. And here this is the imaginary part, and here the imaginary part is B. So B is equal to this minus x it will be minus because here it is positive. So here this will be minus x divided by r square plus x square, r square plus x square. So this is conductance, which is represented by G, and this is susceptance, which is represented by B. So this is about admittance. Don't forget to like, share and subscribe to this channel, and thanks for watching. In this video we will see what is impedance. Impedance is denoted by Z. Impedance is the effective opposition. It is like resistance to the flow of alternating current, that is AC. The unit of impedance is ohm, same like resistance. The unit of impedance is ohm. Impedance is the ratio of voltage and current, but this is in AC. So Z is equal to V by I, that is voltage by current, and the unit of impedance is ohm, which is represented by this omega. In frequency or Phasor domain, for resistor, voltage is equal to current into resistance. This is the Ohm's law. Now impedance is equal to voltage divided by current. So in place of this voltage, if we substitute this value I into R, so this I and this I will get cancelled. So therefore impedance is equal to resistance. This is for only resistor. Then for inductor, we know that in phasor domain or in frequency domain, for inductor, voltage is equal to j omega Li, where omega is the angular frequency, L is the inductance, and this I is the current. So here again impedance is equal to voltage divided by current. So if we substitute voltage value, this j omega Li, so j omega Li, so this I and this I will get cancelled. So therefore impedance is equal to j omega L. So here if we substitute, this omega L is inductive reactance. Omega L is the inductive reactance and it is represented by XL, and the unit of impedance here is ohm. This J represents that voltage leads current by 90 degree, or in another words, current lags voltage by 90 degree for inductor. For capacitor, the voltage and current relationship is given by V is equal to I divided by j omega C. Now, if we substitute the value of voltage here for in impedance formula, so this will be I divided by j omega C into this I as it is. So this I and this I will get cancelled. So 1 upon j omega C. And this 1 upon omega C represents capacitive reactance. This ohm is the unit of this impedance. And this 1 upon omega C is called as capacitive reactance, which is represented by Xc. Now, what if the impedance is the combination of, suppose, resistor, inductor and capacitor? So it is given by, here we can write also Z is equal to R plus Jx, where this R represents resistance, it is the resistance, and this X represents reactance. Now what is this X? So X is equal to XL minus XC. XL is the inductive reactance, XC is the capacitive reactance. Here we can see in this graph, this horizontal axis represents real axis and this vertical axis represents imaginary axis. This resistance, the resistance will be on this horizontal axis or on real axis, and here this will be the XL, that is inductive reactance, and here this will be XC, that is capacitive reactance. And what is this X then? So X will be here, this will be X, which is equal to XL minus XC. Here we can write in bracket, it is XL minus XC. If we take the resultant of this, so it will be something like this. We have to draw the parallel line from here, and then we have to draw the parallel line to this. Then this will be the resultant, which is called as Z. Z is the impedance, and this angle is called as angle phi. So here we can calculate this Z as Z is equal to under root of R square plus X square, or we can calculate this phi as tan inverse of X by R. So we can rewrite this impedance as Z is equal to R plus J. In place of X we can substitute XL minus XC. XL minus XC. Now what is this XL? Again we can rewrite this as Z is equal to R plus J. In place of XL we can substitute omega L, minus in place of XC we can substitute 1 upon omega C. So this is the impedance if there is resistance and inductance and capacitance. So this is about what is impedance. Don't forget to like, share and subscribe to this channel. Thanks for watching. In this video we will see Kirchhoff's laws in the frequency domain. Question: find V of t and I of t in the circuit shown in figure. We have to find this V of t and this I of t in this circuit. Solution: first of all, here we can see the voltage is given. So Vs is equal to 10 cos 4t. Now if we compare this with standard equation, which is V is equal to Vm cos omega t plus phi. So here this Vm is equal to 10. Vm is equal to 10 volts. Vm is the maximum voltage. This omega is the angular frequency, which is equal to 4. So omega is equal to 4 radian per second. 4 radian per second. And here the value of phi is 0. So phi is equal to 0. Also, here we can see the value of capacitance is given. So C is equal to 0.1 farad. The value of resistance is given. R is equal to 5 ohm. We have to find I and V. So we have to find I and we have to find the value of V. Now to find current I, according to Ohm's law, I is equal to V upon Z. This is for AC circuit. So here the voltage is given, it is in time domain format. If we convert this time domain to frequency domain, so it will be 10 at an angle 0 degree. It will be 10 at an angle 0 degree. So it will be 10 at an angle 0 degree divided by impedance Z. So impedance Z is given by, here we can see this resistor and capacitor are connected in series. So therefore impedance Z will be R plus jX. We know that this R is the resistance and this X is the reactance, or we can write it like this, R plus J. This X can be replaced by XL minus XC. Here in this circuit the value of XL is 0, so it will be 0 here, and the value of impedance will be Z is equal to R minus JXC. This XL will be 0 because here the XL value is, the inductance value is not here. So therefore Z is equal to R minus JXC. R minus JXC. So we know that the value of R is 5 ohm and this XC. So let's calculate XC first. XC is equal to 1 upon omega C. So 1 upon the value of omega is, here we can see the value of omega is 4 radian per second. So it will be 4 multiplied with C. The value of capacitance is 0.1 farad. So 0.1 farad, it is equal to 1 upon 4 into 0.1. So it is 2.5, and since it is capacitive reactance, its unit will be ohm. So here the value of I is equal to, we can write 10 at an angle 0 degree divided by the value of resistance R, which is 5 ohm. So this will be 5 minus J, and the value of XC, the value of XC is 2.5. So it is 2.5. Again we know that this is in polar form and this is in rectangular form, and we know that multiplication and division are better performed in polar form. So we will convert this 5 minus J 2.5 into its equivalent polar form. So convert 5 minus J 2.5 into polar form. So this will be 5 minus J 2.5 is equal to R at an angle phi. So the value of R will be under root of x square plus y square. X square plus y square at an angle tan inverse of y by x, where this 5 is x and this 2.5 is y, minus 2.5 is y. So it will be under root of x square, that is 5 square, plus y square, that is minus 2.5 square, at an angle tan inverse of y by x. The value of y is minus 2.5 and the value of x is 5. So it is equal to under root of 5 square plus in bracket minus 2.5 square. So it is 5.59. 5.59 at an angle tan inverse of this. So tan inverse of minus 2.5 divided by 5. It is minus 26.56. minus 26.56 degree. So here we can write I is equal to, let's copy this from here, and it is 5 minus j 2.5 is equal to this. It is in rectangular form and it is in polar form. So here this will be 10 at an angle 0 degree divided by 5.59 at an angle minus 26.56. So therefore I is equal to 10 divided by 5.59, 10 divided by 5.59, it is 1.788, 1.788 at an angle, this will be 0 degree minus 26.56. So this will be plus here, so 26.56 degree. This is the value of current and it is in polar form or phasor form, or we can say it is in frequency domain format. In time domain, we can write it like this: I of t is equal to Im cos omega t plus phi. So I of t is equal to, the value of Im is this 1.788 cos omega. The value of omega is 4 radian per second. So 4t plus the value of phi is 26.56 degree. And since it is current, so its unit will be ampere. Now we have to find the value of this voltage, the voltage across capacitor. So to find voltage across capacitor, V is equal to, it will be we know that the relationship between voltage and current for capacitor is given by V is equal to I divided by j omega c. So we know the value of I, it is 1.788 at an angle 26.56 divided by j. J means 1 at an angle 90 degree. Omega, the value of omega is again 4 radian per second. So it will be 4 multiplied with C. The value of C is, capacitance value is 0.1 farad. So 0.1. So therefore V is equal to 1.788 at an angle 26.56 divided by this 1 into 4 into 0.1. 1 into 4 into 0.1, it is 0.4. 0.4 at an angle 90 degree. So therefore V is equal to 1.788 divided by 4. 1.788 divided by 0.4. So it is 1.788 divided by 0.4, it is 4.47. 4.47 at an angle 26.56 minus 90 degree. So therefore V is equal to 4.47 at an angle 26.56 minus 90, it is minus 63.44 degree. So this is the value of voltage in phasor domain or frequency domain. So in time domain, this will be V is equal to, here we can write this is Vc. So here in time domain, it can be written as Vc or just V of t. This is this voltage. Here we can see this V. So it is equal to Vm cos omega t plus phi. So the value of Vm is 4.47 cos omega. The value of omega is 4 radian per second. So 4t plus the value of phi is, it is minus, so minus 63.44 degree, and since it is a voltage, so its unit will be volts. So this is the voltage across capacitor. So this is how we can find the voltage and current in this circuit. Don't forget to like, share and subscribe to this channel. Thanks for watching. In this video, we will see an example on Kirchhoff's laws in the frequency domain. Question: find V of t and I of t in the circuit shown in figure. We have to find the value of this current and this voltage, which is the voltage across this inductor, and this is a RL series circuit. So solution: first of all, let's copy this circuit. Now we will write what is given. So the value of voltage is given, supply voltage Vs is equal to 20 sin 10t plus 30 degree volt. It is given in time domain format. It is in time domain format. So what we will do, we will compare this with standard equation, that is V is equal to Vm cos omega t plus phi. This is the standard equation. So here we can see, here it is sine and here it is cos. So first we will convert this sine to cos. So let's go to the basics. Here on this horizontal axis, this is plus cos omega t, and here this is minus cos omega t. On this vertical axis, this is plus sin omega t, and here this is minus sin omega t, Now here we have to convert sine to cosine. So we have to convert this sine to cosine. So we are moving from here to here in this direction. So we have to add plus 90 degree to it. So this means we actually want to move from here to here. So here we have to subtract 90 degree. That means sin omega t is equal to cos omega t minus 90 degree. Cos omega t minus 90 degree. So here in place of this sin, if we substitute cos omega t and then minus 90 degree, so it will become cosine. So therefore Vs is equal to 20 as it is. Then in place of this sign we can substitute cos this 10t plus 30 degree as it is, 10t plus 30 degree as it is. Just we have to subtract 90 degree, and since it is a voltage, so its unit will be volts. So now this will be Vs is equal to 20 cos 10t, and this will be minus 60 degree volt. So this is the value of Vs in time domain, and in frequency domain it will be Vs is equal to 20 at an angle minus 60 degree. Here the value of omega is equal to 10 radian per second. Now what we have to find? We have to find I of t. So in frequency domain, I is equal to V upon Z. So here the value of V is Vs, which is 20 at an angle minus 60 degree divided by Z. Now here Z is equal to, here we can see Z is equal to R plus Jx, and we know that X is the reactance, which is equal to XL minus XC. So here XC is absent, that is capacitive reactance is absent here. So it will be R plus JXL only. So therefore Z is equal to R plus JXL. So R plus JXL. So first we have to find the value of this XL. So XL is equal to omega L. The value of omega is 10 and the value of L, that is inductance, it is 0.2 Henry. So 0.2. So this will be 10 multiplied with 0.2. So it is 2, and since it is inductive reactance, so its unit will be ohm. So let's substitute it here. So I is equal to 20 at an angle minus 60 degree divided by resistance. The value of resistance is, here we can see it is 4 ohm. So 4 plus J XL, the value of XL is 2. Now here the numerator is in polar form and the denominator is in rectangular form, and we know that multiplication and division are better performed in polar form. So here we have to convert this into its equivalent polar form. So 4 plus J2 is equal to under root of x square plus y square at an angle tan inverse of y by x. So here this 4 represents x and this 2 represents y. So this should be under root of 4 square plus 2 square at an angle tan inverse of y by x. The value of y is 2 and the value of x is 4. So if we solve this, so it will be under root of 4 square plus 2 square. So it is 4.47 at an angle. Now tan inverse of 2 by 4. So it is 26.56 degree. Now we can substitute it here. So let's copy this directly. And here we can substitute 20 at an angle minus 60 degree as it is. In the denominator, in place of this 4 plus J2, we can substitute this value 4.47 at an angle 26.56 degree. So this will be 20 divided by 4.47. 20 divided by 4.47. It is 4.47 only. So same value we got 4.47. 0.47 at an angle 60 minus 60 minus 26.56 degree. So therefore I is equal to 4.47 at an angle. This will be minus 60 minus 26.56. So it is minus 86.56 minus 86.56 degree, and since it is current, so its unit will be ampere. So this is the value of current in frequency domain. In time domain, it will be I of t is equal to this value 4 point, or first we will write the formula Im cos omega t plus phi. So value of Im is 4.47 cos the value of omega. The value of omega here we can see it is 10 radian per second. So 10 radian per second, 10t plus the value of phi. The value of phi here is minus 86.56 degree, and since it is current, so its unit will be ampere. So this is the value of current. Now we also have to find the value of voltage across the inductor. To find the voltage across inductor, we know that the V and I relation for inductor in frequency domain is given by V is equal to J omega L I. So we have to find the value of voltage. So here this J is 1 at an angle 90 degree. J means 1 at an angle 90 degree. And the value of omega is 10 radian per second. So it is 10 into the value of inductance. The value of inductance is 0.2 Henry. So 0.2 multiplied with current I. Now here the value of current I will be this value 4.47 at an angle minus 86.56 degree. So let's simplify this. So it will be 1 into 10 into 1 into 10 into 0.2 into 4.47. So this will be 8.94 at an angle 90 degree plus, so here we have to add with minus 86.56 degree. So therefore V is equal to 8.94 at an angle 90 plus in bracket minus 86.56. So it is 3.44. Since it is a voltage, so its unit will be volts. So this is in frequency domain format. We have to convert this into time domain. So this will be V of t is equal to Vm cos omega t plus phi. So therefore V of t is equal to, the value of Vm is 8.94 cos omega t. The value of omega is 10. So 10t plus the value of phi is 3.44, and since it is a voltage, so its unit will be volts. So this is the value of voltage in time domain format. Here we can see the voltage is in sine form. So let's convert both the answer in sinusoid form. So here this is the answer for current. So let's copy this, and this is voltage. So first we will convert this current. So this current in sinusoid or sine form will be I of t is equal to 4.47 sine 10t minus 86.56 degree. Now here we have to convert cos to sine. So again here we can see from this graph we have to convert this cos to sine. So that means we are going from here to here like this. So we have to add 90 degree. So the formula will be something like this: sine omega t plus 90 degree is equal to cos omega t. So here we have to add 90 degree to it. So this will be I of t is equal to 4.47 sine 10t, and this will be 86.56 minus 86.56 plus 90 degree. So it is 3.44 plus 3.44, and since it is current, so its unit will be ampere. So this is the final answer for current. And for voltage, this will be, again let's copy this. Let's copy this. Now here we will convert this into sine form. So V of t is equal to 8.94 sine 10t plus 3.44 plus 90 degree volts. So therefore V of t is equal to 8.94 sine 10t, and this will be plus 93.44, and since it is a voltage, so its unit will be volts. So this is the final answer in sine form. So this is how we can find current and voltage in sine form. Don't forget to like, share and subscribe to this channel, and thanks for watching. In this video we will see impedance in a series circuit. So here we can see this is a circuit, and here the impedances are connected in series. Z1, Z2 and Z3, these are the three impedances. These are connected in series. This is a voltage source with voltage Vs, and this is the total current I. Voltage across impedance 1 is V1, voltage across impedance 2 is V2, and voltage across impedance 3 is V3. In frequency domain, we know that Zeq, that is, this Zeq is the total impedance. It will be equal to Vs upon I. Vs is the source voltage upon total current I. And here this Zeq, that is Z equivalent, is equal to Z1 plus Z2 plus Z3. So we have to add all the three impedances when they are connected in series. Now Vs is equal to V1 at an angle phi 1 plus V2 at an angle phi 2 plus V3 at an angle phi 3. This phi 1, phi 2 and phi 3, these are the phase angles of voltage V1, V2 and V3 respectively. But remember that in time domain, Vs of t is not equal to V1 plus V2 plus V3. So here remember that it will not be equal to V1 plus V2 plus V3. So this is about impedance in a series circuit. Don't forget to like, share and subscribe to this channel. Thanks for watching. In this video we will see impedances in a parallel circuit. So here this is a case 1 when a circuit contains only two impedances in parallel. So here this is a voltage source Vs, this is a total current I, this is impedance Z1 and this is impedance Z2. Z1 and Z2 are connected in parallel. So their equivalent impedance will be 1 upon Zeq. This Zeq is the equivalent impedance. So it is equal to 1 upon Z1 plus 1 upon Z2. Same like we do for resistances. So if we simplify this, so Z equivalent is equal to Z1 into Z2 divided by Z1 plus Z2. Now what if there are more than two impedances connected in parallel? So here we have taken an example with three impedances in parallel. So that will be 1 upon Zeq is equal to 1 upon Z1 plus 1 upon Z2 plus 1 upon Z3. Now here we know that 1 upon Z, that is reciprocal of impedance, is equal to admittance. So to simplify this, we can use this admittance. We can replace 1 upon Z1 with Y1, that is admittance 1. 1 upon Z2 we can replace it with Y2, and 1 upon Z3 we can replace it with Y3. After simplifying or after adding all of these three, we can again reconvert this into impedance form if we want, because we know that Y, that is admittance, is equal to 1 upon Z, that is impedance. So this is about impedances in a parallel circuit. Don't forget to like, share and subscribe to this channel, and thanks for watching. In this video we will see current divider in parallel branches with impedances. Before starting this video, don't forget to like, share and subscribe to this channel. So here we can see this is a total current I, this is current I1 in impedance 1. So let's say this is branch 1 and this is branch 2 with current I2 and impedance Z2. So according to Kirchhoff's current law, we know that total current or summation of all the currents entering a node is equal to summation of all the currents leaving the node. So this I should be equal to I1 plus I2. Now according to current divider rule or current division rule, we know that I1 is equal to I into Z2 divided by Z1 plus Z2, and I2 is equal to I multiplied with Z1 divided by Z1 plus Z2. Now this is the current division rule. We know that if we want to find current I1, that time what we do, we take total current and then multiply it with parallel branch. So parallel branch to this Z1 is Z2. So here in the numerator we take Z2 and divided by total of this Z1 plus Z2. Similarly for I2, if we want to find this current I2, then we take the total current I, then multiply it with opposite branch resistance or parallel branch resistance. Here it is Z1. So in the numerator it will be Z1 divided by Z1 plus Z2. We can verify our answer. If we add Z1 and Z2, then we get, if we add I1 plus I2, then we get I1 plus I2 is equal to this I into Z2 divided by Z1 plus Z2, then plus I into Z1 divided by Z1 plus Z2. So here we can take this I and Z1 by Z2 common. So I divided by Z1 plus Z2. So I divided by Z1 plus Z2, and what's remain then? Z2 and this Z1. So Z2 plus Z1, or we can say Z1 plus Z2, both are same. So here this Z1 plus Z2 and this Z2 plus Z1 will get cancelled. So what's remain? Only I. So therefore I1 plus I2 is equal to I. So hence both I1 and I2 currents are correct. So this is about current divider in parallel branches with impedance. Thanks for watching. In this video we will see delta to Y transformation. Before that, don't forget to like, share and subscribe to this channel. Also, if you want to invest in share market or in real estate, check the links in the description below. So let's see. Here we can see this ZA, ZB and ZC forms a delta connection, and this Z1, Z2 and Z3 forms a Y connection. So let's see. If we have a delta connected network and we want to convert it into its equivalent Y connection, then we need Z1. The value of Z1 will be ZB into ZC. ZB into ZC divided by ZA plus ZB plus ZC. ZA plus ZB plus ZC. Same for Z2. It will be, if we want to find this Z2, then we need to multiply ZA into ZC. So ZA into ZC divided by ZA plus ZB plus ZC. Now same for Z3. So Z3 is equal to ZA into ZB, ZA into ZB divided by ZA plus ZB plus ZC. ZA plus ZB plus ZC. So this is the formula for Z1, Z2 and Z3 for Y connection. So this is how we can transform the delta connected network into its equivalent Y connected network. Thanks for watching. In this video we will see Y to delta transformation. Before that, don't forget to like, share and subscribe to this channel. Also, if you want to invest in trading or share market or in real estate, then check the link in the description below. Here we can see this inner connection is called as Y connection. The Z1, Z2 and Z3 forms a Y connection because it looks like Y, so that's why it is called as Y connection or star connection. And here the outer part ZA, ZB and ZC. If we have the value for Z1, Z2 and Z3 and we have to find ZA, ZB and ZC. So ZA is equal to, what we have to do, we have to multiply Z1 into Z2. So it will be Z1 into Z2. Then Z2 into Z3. Z2 into Z3, then plus Z3 into Z1. Z3 into Z1 divided by, now here we are finding this ZA, so we have to take in denominator here, we have to take this Z1. So this Z1 will be here. Then similarly for ZB, the numerator will be same, that is Z1 into Z2 plus Z2 into Z3 plus Z3 into Z1 divided by, now this time we have to find this ZB, so it will be divided by this Z2. Now similarly for ZC, the numerator part will be same, that is Z1 into Z2 plus Z2 into Z3 plus Z3 into Z1. Z3 into Z1 divided by, we have to find this ZC now. So it will be divided by this opposite part, that is Z3. So this is how we can convert Y to delta. This is called as Y to delta transformation. Thanks for watching. If you want to invest your fund in stocks or trading or in real estate, then check the links in the description below. In this video, we will see impedance combinations. Question: find the input impedance of the circuit in figure. Assume that the circuit operates at omega is equal to 50 radian per second. So for this circuit, we have to find its input impedance, that is Zin, and we have to assume that the angular frequency is 50 radian per second. So solution. So let's solve this. Now here we can see, let's assume this as Z1, and let's say this is Z2. This is Z2, and here this is Z3. So first of all, let's calculate or simplify Z1. Impedance Z1 will be, we know that for capacitor it is 1 upon j omega c. So it will be 1 upon j, the value of omega. The value of omega is 50. So 50 multiplied with c. The value of capacitance is 2 millifarad. So 2 into 10 to the power minus 3. So if we simplify this in calculator, so it will be, we have to put the calculator in complex mode. So I into 50 multiplied with 2 into 10 to the power minus 3. So it is minus 10i or 10j. Now similarly for Z2 will be, it is the combination of resistance and capacitance. So it will be R plus jx. Here we know that this x is the reactance and this R is the resistance. So here the resistance will be R plus j. X is XL minus XC, but here the value of, for Z2, the value of inductive reactance will be 0. So this will be R minus jXC. Now what is this XC? So again Z2 is equal to R minus J, and this XC means 1 upon omega C. 1 upon omega C. So let's substitute all the values. The value of resistance, here we can see it is 3 ohm. So 3 minus j, 1 upon the value of omega. The value of omega is 50. So it will be 50 multiplied with the value of capacitance, that is 10 millifarad. So 10 into 10 to the power minus 3. So let's simplify this in calculator directly. So 3 minus I into 1 upon 50 into 10 into 10 to the power minus 3. So it is 3 minus 2j. So this is the value for Z2. Let's say this is equation number 1. This is equation number 2. Now next is Z3. So Z3 is equal to, we know that Z3 is equal to R plus jx, where this x is R plus j XL minus XC. So therefore Z3 is equal to, here we can see for Z3 the value of resistance is 8 ohm. So it will be, before that we can substitute the value of XC 0, because for Z3 the value of capacitance is not there, so it will be 0. So we can put it like R plus j XL only, this XC will be 0. And we know that XL is equal to omega L. So let's put the value of resistance R. So it will be 8 ohm for Z3. So 8 plus J, the value of omega. The value of omega is again 50 multiplied with the value of inductance. The value of inductance is 0.2 Henry. So 0.2. So it is equal to 8 plus J into 50 into 0.2. So it is 8 plus 10J. 8 plus 10J. This is equation number 3. Now we got the values of Z1, Z2 and Z3. So here we can see the Zin will be equal to, again let's copy this circuit. Let's copy this circuit one more time. So Zin will be equal to, the Z1 is in series with Z2 parallel with Z3. So it will be Z2 into Z3 divided by Z2 plus Z3, because the Z2 and Z3 are connected in parallel and they are connected in series with Z1. So now let's substitute the values of Z1, Z2 and Z3 from this equation number 1, 2 and 3 respectively. So therefore Zin is equal to, the value of Z1 is minus 10J. So minus 10J, then plus the value of Z2. The value of Z2 is 3 minus 2J. 3 minus 2J. And the value of Z3 is 8 plus 10J. 8 plus 10J, again divided by same, that is 3 minus 2J plus 8 plus 10J. So let's simplify this. So it will be minus 10J plus 3 minus 2J into 8 plus 10J divided by, we can add the real parts first. So it will be 3 plus 8, 11. Then this will be minus 2 plus 10. So it will be plus J 8. First we have to add the real parts, and then after that we have to add the imaginary parts. Now here for the numerator we have to do multiplication, and we know that multiplication and division are better performed in polar form. Currently it is in rectangular form. So let's convert this into its equivalent polar form. So this 3 minus 2J, let's convert this first. 3 minus 2J is equal to, it will be under root of x square plus y square at an angle tan inverse of y by x, where this 3 is x and this minus 2 is y. So this will be under root of x square means 3 square plus y square means minus 2 square at an angle tan inverse of y by x. So it is minus 2 by 3. So minus 2 by 3, this will be under root of 3 square plus in bracket minus 2 square. So it is 3.6. 3.60 at an angle tan inverse of -2/3. So it is -33.69 -33.69 degree. Now we will do the same for 8 plus 10j. So it will be 8 plus 10j is equal to, we can directly calculate it, under root of 8 square plus 10 square at an angle tan inverse of 10/8. So this will be under root of 8 square plus 10 square. So it is 12.80 at an angle tan inverse of 10/8. So it is 51.34 degree. Now let's multiply this, or we can also convert this 11 plus j8 first. So let's convert it. 11 plus j8. So this will be under root of 11 square plus 8 square at an angle tan inverse of 8/11. So this will be under root of 11 square plus 8 square. So it is 13.60 at an angle tan inverse of 8/11. 36.02 degree. So now let's put all these values here. So let's copy this again, and it is equal to, so we can put this minus 10j as it is, then plus, in place of this 3 minus 2j we can substitute this 3.60, or let's copy this directly. Then multiply it with 8 plus 10j. In place of 8 plus 10j we can substitute 12.80 at an angle 51.34 divided by, now in place of this 11 plus j8 we can substitute this value 15.60 at an angle 36.02 degree. So here we have to multiply this first. So let's simplify it. So it will be minus 10j plus 3.60 into 12.80. 3.60 into 12.80. So it is 46.08. 46.08 at an angle. We have to add this minus 33.69 degree plus 51.34 degree divided by 13.60 at an angle 36.02 degree. So this will be minus 10j plus 46.08 at an angle. Now this will be minus 33.69 plus 51.34. So it is 17.65 divided by 13.60 at an angle 36.02. Now here we have to do division of this polar form. So it will be minus 10j plus this will be 46.08 divided by 13.60. So it is 3.38 at an angle. This will be 17.65 then minus 36.02. So it will be minus 10j then plus 3.38 at an angle. This will be 17.65 minus 36.02. So it is minus 18.37 minus 18.37 degree. So here this is in polar form and this is the value of z in. So it is in polar form and it is in rectangular form. So first we have to convert. We know that addition and subtraction are better performed in rectangular form. So it will be 3.38 at an angle minus 18.37 degree. So it will be r in bracket cos phi plus j sin phi. So it will be 3.38 cos, the value of phi is minus 18.37 plus j sin minus 18.37 degree. So this will be 3.38 in bracket cos minus 18.37 then plus I into sin minus 18.37. So it is 3.20 then minus j 3.20 minus j 1.06. So we can substitute here. Let's copy this again. Now in place of this we can substitute this value. Z in is equal to minus 10j plus 3.20 at an 3.20 minus j 1.06. So therefore Z in is equal to, the real part is 3.20 and this will be 11 point minus 11.06 j. So this is the value of Z in rectangular form. Since it is impedance, so its unit will be ohm. So this is how we can solve impedance combination question. Thanks for watching. If you want to invest your fund in stocks or in trading or in real estate, then check the links in the description below. In this video, we will see impedance combinations question. Determine the input impedance of the circuit in figure at omega is equal to 10 radian per second. Here for this circuit, we have to find its input impedance. So solution. First of all, let's assume this is Z1. Let's say this is Z1, this is Z2 and this form Z3. Now here we can see Z1 is the combination of capacitor and resistor. So Z1 will be equal to R plus Jx, and we know that X is equal to R plus Jxl minus Xc. Here the value of inductive reactance will be 0. So this will be R plus, not plus, this will be minus Jxc. So therefore Z1 is equal to R plus J. Now in place of Xc, Xc is equal to 1 upon omega c. Again here this is minus, not plus. So R minus J 1 upon omega c. The value of resistance is 80 minus J 1 upon omega. The value of angular frequency is 10. So this will be 10 into the value of capacitance. The value of capacitance is 0.5 millifarad. So 0.5 into 10 to the power minus 3. So if we simplify this, so it will be 80 minus J, and this will be 1 upon 10 into 0.5 into 10 to the power minus 3. So it is 200. Let's say this is equation number 1. Now next is Z2. So Z2 is only this capacitor. So this will be only minus Jxc, or we can write full equation, that is R plus Jx is equal to, the value of resistance is 0, and this will be J in bracket XL minus, or let's write full again. So it will be R plus J XL minus Xc. So the inductive reactance is also 0 and the resistance is also 0. So this will be minus Jxc only, and we can write Xc as, so minus J as it is, and this will be 1 upon omega c. So minus J 1 upon the value of omega is 10 into the value of capacitance is 1 millifarad. So it will be 1 into 10 to the power minus 3. So this will be minus J, and here this will be 1 upon 10 into 1 into 10 to the power minus 3. So it is 100. Let's say this is equation number 2. Now for Z3. So here Z3 is the combination of inductance and resistance. So again we will write the full equation. So it is R plus Jx. So it will be R plus J in bracket XL minus Xc. So here the value of capacitive reactance is 0. Here we can see the capacitive reactance is 0. So this will be only R plus Jxl. So Z3 is equal to, the value of resistance is 200. So 200 plus J XL. XL we can write it as omega L. So this will be 200 plus J, the value of omega is 10, into the value of L. The value of L is 8 Henry. So it is 8. So it is equal to 200 plus J, this will be 80. So this is equation number 3. Now here we can see Z in. Again let's copy this. So for this, here we can see, let's erase this. Z in is equal to, Z1 is in series, so Z1 plus this Z2 and Z3 are connected in parallel. So this will be Z2 into Z3 divided by Z2 plus Z3. Now let's simplify this and put all the values here. So this will be Zin is equal to, the value of Z1 is 80 minus J200. So 80 minus J200 plus the value of Z2 is minus J100. So minus J100 into the value of Z3. It is 200 plus J80. 200 plus J80 divided by same minus J100 plus 200 plus J80. So therefore Zin is equal to this value. So let's simplify this. So it will be 80 minus I into 200 plus, let's put all the values. So it is in bracket minus I into 100 into 200 plus I into 80 divided by minus 100 into I, then plus 200 plus I into 80. So it is 129.50 minus J 295.04, and since it is impedance, so its unit will be ohm. So this is how we can find input impedance. Don't forget to like, share and subscribe to this channel, and thanks for watching. If you want to invest your fund in stocks or in trading or in real estates, then check the links in the description below. In this video, we will see impedance combinations. Question: determine VO of T in the circuit of figure. So here for this circuit we have to find this VO, which is the voltage across this inductor. So solution for this will be, here we can see currently it is in time domain format. So convert it into frequency domain format. Frequency domain. So here it is 20. It is a voltage source. So it is Vs is equal to 20 cos 4t minus 15 degree. So it is in time domain. Now this in frequency domain will be capital Vs is equal to 20 at an angle minus 15 degree, and since it is a voltage, so its unit will be volts. So it is in frequency domain. Now here this is the value of a resistor. So here we can write 60 ohm will be 60 ohm. This 10 millifarad. So this 10 millifarad will be converted like this, minus J 1 upon omega C. So minus J as it is, so 1 upon the value of omega. Here we can see the value of omega is this is the value of omega 4. This 4 is the value of omega. So here we can write omega is equal to 4 radian per second. So this will be 4 multiplied with capacitance value is 10 millifarad. So 10 into 10 to the power minus 3. So this will be minus J, and this will be 1 upon 1/4 into 10 into 10 to the power minus 3. 4 into 10 into 10 to the power minus 3. So it is 25. 25. Then this 5 Henry. So this 5 Henry, currently it is in time domain format. In phasor domain or frequency domain, this will be j omega L. So j, as it is, the value of omega is 4 into the value of inductance is 5. So this will be j 20. Now we got the value of resistance, capacitance and inductance in frequency domain. So let's paste the circuit again and change all these values in frequency domain form. So first, the voltage source value will be 20 at an angle minus 15 degree volt. 20 at an angle minus 15 degree volt. This 60 ohm will be as it is. This 10 millifarad will be replaced by minus j 25. So this will be minus j 25 and this 5 Henry will be replaced by j 20. Only j 20. So now we can easily simplify this. So what we have to find? We have to find this voltage VO. So first we need to find this current. So let's say this current is current IO and this is the total current I. So now let's assume this is impedance 1. Let's say this is Z1, this is Z2 and this is Z3. So impedance will be ZEQ is equal to Z1 is in series with Z2 parallel with Z3. So Z2 into Z3 divided by Z2 plus Z3. So let's put all the values. So Z1 value is 60 plus Z2 value is minus J25 into J20 divided by minus J25 plus J20. So therefore Z equivalent is equal to, let's put these values in calculator directly. So 60 plus in bracket minus I into 25 into I into 20 divided by minus I into 25 plus I into 20. So it is 60 plus 100J, 60 plus 100J. So this is the value of impedance and its unit will be ohm. Now we can easily find the value of current I. So currently it is in frequency domain format. So these values will be in capital. So this is capital I and this is capital IO and this will be capital VO. So now we can easily find the value of current I. So I is equal to V upon ZEQ. So the value of voltage is, here we can see it is 20 at an angle minus 15 degree. 20 at an angle minus 15 degree divided by ZEQ. So it is 60 plus 100J. So let's solve this in calculator, or we can simplify this manually also, but we can directly solve this in calculator. So 20 at an angle minus 15 divided by 60 plus 100 into I. So this will be 0. Again this is in rectangular form. So let's convert these values into its equivalent polar form. So shift 2 and 3. So it is 0.171 at an angle minus 74.03, and since it is current, so its unit will be ampere. Now next we can easily find the value of current IO by using current division rule. So by using current division rule, IO is equal to this current, that is total current I multiplied with opposite branch resistance, that is Z2. So Z2 divided by Z2 plus Z3. So Z2 plus Z3. So let's substitute all the values. The value of current I is 0.171 at an angle minus 74.03 into the value of Z2. The value of Z2 is J minus J25. So minus J25 divided by minus J25 plus here the value of Z3 J20. So J20, again we can solve this in calculator directly. So IO is equal to this 0.171 at an angle minus 74.03 into minus I into 25 divided by minus I into 25 plus I into 20. So this answer is in rectangular form again. So in polar form this will be 0.855 at an angle minus 74.03 degree, and since it is current, so its unit will be ampere. Now we have to find VO. So VO is equal to this IO multiplied with J20. So J20, again the value of IO is this 0.855 at an angle minus 74.03 degree into J20. So therefore VO is equal to 0.855 at an angle minus 74.03 into I into 20. So it is this value 16.44 plus J 4.70, and since it is a voltage, so its unit will be volts. So this is the value of VO in rectangular form. Again we will convert this into its equivalent polar form. So shift to 3, it is 17.1. So VO is equal to 17.1 at an angle 15.97 volts. Now it is in frequency domain. We will convert this into time domain. So it will be VO of t is equal to 17.1 cos omega t. the value of omega is, we know that the value of omega is 4 radian per second. So it will be 4t plus 15.97, and since it is a voltage again, so its unit will be volts. So this is the answer in time domain format. So it is in time domain. So this is how we can find VO of t of this circuit. Don't forget to like, share and subscribe to this channel. Thanks for watching. If you want to invest your fund in stocks or in trading or in real estates, then check the links in the description below. In this video, we will see impedance combination example. Question: calculate VO in the circuit of figure. Here in this circuit, we have to find this VO. Solution: as we can see, this circuit is in time domain format. So first of all, we will convert this into its equivalent frequency domain form. So convert it into its equivalent frequency domain. So here this is a voltage source. So Vs is equal to 20 cos 10t plus 100 degree. Now it is in time domain format. So convert it into its equivalent frequency domain. This will be capital Vs is equal to 20 at an angle 100 degree. And the value of omega is equal to 10 radian per second. So this is in frequency domain. Now here this is 0.5 Henry. So the value of this inductance in frequency domain will be 0.5 Henry. This will be converted like J x L. So this will be J into omega L. So this will be J into the value of omega is 10 and the value of inductance is 0.5. So this will be 5 J 5. Now for this 10 ohm, this will be 10 ohm in frequency domain will be 10 ohm. Then 1 by 20 farad. So 1 by 20 farad, this will be minus J x C. So this will be minus J 1 upon omega C. So minus J 1 upon the value of omega is 10 and the value of capacitance is 1 by 20. So 1 by 20. If we simplify this, so it will be 1 upon 10 into 1 by 20. So it is 2. Now we got all the values in frequency domain form. So let's replace these values. So this 20 cos 10t plus 100 degree will be replaced by this value 20 at an angle 100 degree. So 20 at an angle 100 degree. This 10 ohm will remain as it is. Here we can see this 10 ohm will remain as it is, but this 0.5 Henry, this will be replaced by J5. So this will be J5 and this 1 by 20 farad will be replaced by minus J2. So we have to find the value of this current I. and then we have to multiply this I with this value, then we get the value of VO. So let's find the value of impedance first. Let's say this is Z1 and this is Z2. So here this J5 ohm and 10 ohm. This J5 and this 10 ohm are connected in parallel. So this will be, first let's simplify this. So J5 parallel with 10. So it will be J5 into 10 divided by J5 plus 10. So this will be 5 into 10 divided by I5 plus 10. So it is 2 plus 4J. So again we have to add this. Let's say this is Z1, this is impedance Z1 and this is Z2. So total impedance will be ZEQ is equal to Z1 plus Z2. So this is the value of Z1. So it is 2 plus 4J plus the value of Z2 is minus J2. So therefore ZEQ is equal to, this will be 2 and this will be plus 2J. This is the value of impedance in rectangular form. Now we can easily find the value of total current I. So total current I is equal to V upon ZEQ. The value of voltage is 20 at an angle 100 degree. 20 at an angle 100 degree divided by ZEQ is 2 plus 2J. So let's solve this in calculator directly. So 20 at an angle 100 divided by 2 plus 2 into I. So this will be 4.05. This is in rectangular form. Let's convert it into its equivalent polar form. So shift 2, 3. So it is 7.07 at an angle 55. Since it is current, so its unit will be ampere. Now we can easily find the value of VO. So VO is equal to current I multiplied with impedance Z2. So the value of current I is 7.07 at an angle 55 multiplied with Z2. The value of Z2 is minus J2. So minus J2. So therefore VO is equal to, let's solve this in calculator directly. 7.07 at an angle 55 7.07 at an angle 55 into minus I into 2. So this is the answer in rectangular form. In polar form, this will be shift 2, 3. So it is 14.14 at an angle minus 35 degree. And since it is a voltage, so its unit will be volts. And this answer is in frequency domain form and it is in polar form. And we need answer in time domain format. So VO is equal to, VO of t is equal to 14.14 cos omega t. The value of omega is 10. So it is 10 t and minus 35 degree. And since it is a voltage, so its unit will be volts. And it is in time domain. Time domain. So this is the final answer for this question. Also remember that here we have compared this equation with the standard equation is V is equal to Vn cos omega t plus phi. Here also the equation will be Vo is equal to Vm cos omega t plus phi. This minus 35 is the phase angle. So this is how we can find the value of Vo. Don't forget to like, share and subscribe to this channel. Thanks for watching. If you want to invest your fund in stocks or in trading or in real estates, then check the links in the description below. Also, don't forget to like, share and subscribe to this channel. In this video, we will see impedance combinations. Example, question, find current I in the circuit of figure. For this circuit, we have to find this current I. As we can see, the values are given in frequency domain format. So it is very easy to find. We can directly find the value of this current I just by dividing voltage by impedance. So first we need to find the value of equivalent impedance or ZEQ or total impedance. So solution, as we can see, this forms a star connection or Y connection. So first we will convert this Y into its equivalent delta. So let's take this much part from here. Let's copy it and paste it here. So here we can write convert Y to delta. Convert Y to delta. So here we can see this is A, this is B and this point is C. And let's say this point is O. So this will be, let's say this is Z1, this is Z2 and this is Z3. So now we have to find AO, then AC and CO. So first we will find ZAO. So ZAO is equal to, this will be Z1 into Z3 into, it will be like this, Z1 into Z3 plus Z3 into Z2, Z3 into Z2, then Z2 into Z1, Z2 into Z1 divided by, we have to divide this by, currently we are finding between this A and this O. So we are finding this value here. It will be something like this. We are finding this value of impedance ZAO. So it will be divided by this 8 ohm, that is Z2. Now let's substitute all these values here. So Z1 value is J4 into Z3 value is minus J3 plus Z3 again minus J3 into Z2 value is 8, then plus Z2 value is again 8 ohm into Z1 value, it is J4 divided by Z2, which is 8 ohm. So this will be the value of ZAO. Now for all the parts of this ZAO, ZOC and CA. So the numerator will remain same. So let's simplify this in calculator directly. ZAO will be equal to, we have to take the calculator in complex mode. So this will be I into 4, then into minus I into 3, then plus in bracket minus I into 3 into 8 plus 8 into in bracket I into 4 divided by 8. So it is 1.5 plus J. 1.5 plus J. Since it is impedance, so its unit will be ohm. Then next we have to find this impedance. So it will be ZCO, let's say. So ZCO will be equal to, here we can write ZCO is equal to, again the numerator will remain same. So same formula, just we have to replace the denominator part. The denominator will be, for this ZCO, the denominator will be this Z1. So Z1. Again, we can directly copy this part. So let's copy it from here and paste it here. Now the denominator will change to Z1. The value of Z1 is J4. So this will be J4. So ZCO is equal to, just we have to replace the denominator, I into 4. So it is 2 minus 3J. 2 minus 3J. Then next is ZAC. ZAC. We have to find the ZAC. This is ZAC. So ZAC will be equal to, again same formula, just we have to replace the denominator part. We are converting from star connection or Y connection to delta connection. So now the denominator for ZAC will be, the opposite of this is Z3. So here this will be Z3. So ZAC is equal to, again the numerator will be same. The numerator will remain same, but the denominator part will change. It will be Z3, that is minus J3. Minus J3. So therefore ZAC is equal to, just we have to replace the denominator part to minus I into 3. So it is 2.66 minus 2.66 plus 4J plus 4J ohm. Also this is ohm since it is impedance. Now we can easily redraw the circuit and change the star network to delta network. So let's copy this. Now here we can erase this internal star and replace this by its equivalent delta connection. So the equivalent delta will look something like this. So now this will be ZAC. Let's say we are assuming this as O. So this is ZAO and this is ZCO. So let's put all the values of ZAC, ZAC, ZAO and ZCO. So first let's put the value of ZAO. It is 1.5 plus J. 1.5 plus J. Now the value of ZCO value is 2 minus 3J. So 2 minus 3J. And the value of ZAC is minus 2.66 plus 4J. So now we can easily simplify this. As we can see, these two are in parallel. Also these two are in parallel and both are in series. So let's simplify the circuit and find the value of ZEQ. So this will be, also let's assume this as, we are assuming this as, let's say this is Z1 and this is Z2 and this is Z3. So now we can easily simplify this. So Z1 is parallel with ZAC. So we can write full ZEQ as ZEQ is equal to Z3 in series with, it is in series with these two parallel resistance. So let's take this in square bracket like this. So here we can write Z1 parallel with ZAC. Then it is in series with Z2 parallel with ZCO. Now they both are parallel with ZAO. So they are both parallel with ZAO. So it will look something like this. Can you erase this bigger part? So here we can see again Z3 is in series with Z1 parallel with ZAC. It is in series with Z2 parallel with ZCO and both are connected in parallel with ZAO. So let's simplify this now. So it will be something like this: Z3 plus, in square bracket, this will be Z1 into ZAC divided by Z1 plus ZAC, then plus Z2 into ZAC, ZCO divided by Z2 plus ZCO. Then it is parallel with ZAO. So first we will find this value inside the bracket. So let's take this value and we will find this first. So this part will be equal to, let's put all the values of Z1 and ZAC. So Z1 value is 2 minus J4. So let's put it here, 2 minus J4 multiplied with 2 minus j4 multiplied with minus 2.66 plus 4j, minus 2.66 plus j4 or 4j. Now they will be divided by same value but in addition. So again 2 minus j4 plus minus 2.66 plus j4, then plus, now the value of z2. The value of z2 is 8 plus j6, 8 plus j6 in one bracket, and in another bracket this will be 2 minus 3j, 2 minus 3j. So this will be divided by same value, 8 plus j6 plus 2 minus 3j. So this will be, let's simplify this in calculator directly. So 2 minus I into 4 into minus 2.66 plus 4 into I divided by 2 minus I into 4 plus minus 2.66 plus I into 4, then plus, again this part is in bracket 8 plus I into 6 multiplied with 2 minus 3 into I divided by same value, 8 plus I into 6, then plus 2 minus 3 into I. So this will be this much value, minus 13.39. So let's convert this value into its equivalent polar form. Let's see. First we have to find the value in polar form. We have to find the value in frequency domain. So let's take this value in polar form. So it will be shift 2 and 3. So it is 33.10, 33.10 at an angle minus 113, minus 113.86, and since it is impedance, so its unit will be ohm. So we got the value for this part only. Now we will multiply this value with ZAO. So again let's copy this part. Let's put all the values here. Now we can easily substitute the value of Z3. So the value of Z3 is 12. So 12 plus the value of this part is this much. So let's put it there, and we have to multiply it and divide it. We have to do this parallel operation of this value. So this will be 33.10 at an angle minus 113.86. It is multiplied with ZAO. The value of ZAO is 1.5 plus J. 1.5 plus J, then same value divided by 33.10 at an angle minus 113.86 plus 1.5 plus J. So this will be the value of ZEQ. Let's put all the values in calculator. So 12 plus, so here this will be 33.10 at an angle minus 113.86 multiplied with 1.5 plus this I divided by 33.10 at an angle minus 113.86 bracket close plus in bracket 1.5 plus j. We can delete this bracket. So now the answer will be this much, 13.60 plus j 0.999. Now we can easily convert this into its equivalent polar form. So shift to 3. So it is 13.63 at an angle 4.2 degree, and since it is impedance, so its unit will be ohm. So therefore ZEQ is equal to 13.63 at an angle 4.2 degree ohm. But we have to find the value of current I, and we know that current I is equal to V upon ZEQ. Now let's substitute the value of voltage V. It is 50 at an angle 0 degree. 50 at an angle 0 degree divided by this value 13.63 at an angle 4.2. So if we solve this in calculator, so it will be 50 at an angle 0 divided by 13.63 at an angle 4.2. So this will be 3.65, or we can directly get the value in polar form. So shift 2 and 3. So it is 3.66 at an angle minus 4.2, and since it is current, so its unit will be ampere, and here this will be degree. So therefore current I is equal to 3.66 at an angle minus 4.2 degree ampere. So this is the answer for current in phasor domain format or in frequency domain. Don't forget to like, share and subscribe to this channel, and thanks for watching. If you want to invest your fund in trading or in stocks or in real estates, then check the links in the description below. In this video, we will see an example on impedance combinations. Question: find I in the circuit of figure. For this circuit, we have to find its total current I. Solution: here we can see this upper part forms a delta connection. So what we will do, we will convert this delta to star connection, then we will simplify the circuit. So let's convert this delta into its equivalent star connection. So here it will look something like this. First let's change this 8 ohm here and this J5 ohm here. Now we can easily draw the inner star connection. So it will look something like this. And here this will be like this. So this is ZA, this is ZB, and this is ZC. So from here ZA is equal to J4 into minus J3 divided by J4 plus minus J3, then plus J4, then minus J3, then plus this 8 plus J5. So let's simplify this in calculator directly. So it will be I into 4 multiplied with minus I into 3 divided by I into 4 plus minus I into 3 plus 8 plus I into 5. So this is 0.96 minus 0.72 J, and since it is impedance, so its unit will be ohm. Now we will find ZB similarly. So ZB is equal to minus J3 into this 8 plus J5 divided by same denominator J4 plus minus J3 plus 8 plus J5. If we solve this, so it will be we have to replace this part only. So it will be in bracket 8 plus I into 5. The denominator will remain same. So it is 0. Minus 0.24 minus 0.24, then minus 2.82 J. And since it is impedance again, so its unit will be ohm. Now same for ZC. So again let's copy this part. Only we have to change the numerator part. So the numerator part for ZC will be this into this J4 into this part 8 plus J5. So just we have to change this J4 plus J4 will be here J4. So it will be equal to just change this part. So I into 4. So it is 0.32, then plus 3.76 J. 3.76 J. And again its impedance, so its unit will be ohm. Now again if we copy this circuit, so this will be changed now. Now we can write the values of this ZA, ZB and ZC, or we can directly simplify it. So if we directly simplify this, then the circuit will look something like this. So again, let's copy this circuit and paste it here. We have to change this part. So it will look something like this. So here this will be ZA. The value of ZA is 0.96 minus 0.72 J. 0.96 minus J 0.72, and since it is impedance again, so its unit will be ohm. Now we will write here, this will be ZB plus 10. So the value of ZB is this value 0. So let's add it here directly, minus 0.24 minus 2.82 into I plus 10. So it will be 9.76 minus 2.82 J ohm. 9.76 minus 2.82 J ohm. And here this will be ZC plus this. So the value of ZC is this value 0.32 plus 3.76 into I. Then it will be added with this 5 plus 5, then minus I into 2. 5 minus I into 2. So this will be 5.32. 5.32, then plus 1.76, 5.32 plus J 1.76. So now we can easily find the value of ZEQ. So ZEQ will be equal to this value 0.96 minus J 0.72, then plus this into this divided by this plus this. So it will be 5.32 plus J 1.76 into 9.76 minus 2.82 J divided by 5.32 plus J 1.76 plus 9.76 minus 2.82 J. So this will be equal to ZEQ is equal to 0.96 minus I into 0.72, then plus it will be 5.32 plus I into 1.76 multiplied with 9.76 minus 2.82 into I divided by 5.32 plus I into 1.76 plus 9.76 minus 2.82 into I. So this will be 4.70 minus 0.31 J, and since it is impedance, so its unit will be again ohm. So now we can easily find the value of current I. So I is equal to V upon ZEQ. The value of V is 30 at an angle 0 degree. 30 at an angle 0 degree divided by ZEQ. So let's copy this from here directly and paste it here. If we solve this in calculator directly, so it will be 30 at an angle 0 divided by 4.70 minus 0.31 into I. So it is this value 6.34 plus 0.417 J, and since it is current, so its unit will be ampere. So we can convert it into polar form. Currently it is in rectangular form. So this will be equal to shift 2 and 3. So it is equal to 6.35 at an angle 3.76 ampere. So this is the value of current I. Don't forget to like, share and subscribe to this channel. Thanks for watching.